Hi, welcome to build REST API with Spring Boot and JPA on my YouTube channel. If you're following my YouTube channel from the longest time, you probably know that already there is a playlist on my YouTube channel which is REST API with Spring Boot and JPA, which I have created in 2019. Since then, so many things have been changed. I just want to recreate that playlist with the new concepts, with the new tools. So that's why here we are, and in this video course I will teach you everything you need to know about creating the REST API with the Spring Boot and JPA. Alright, let's begin. So what is REST API? So REST API, or the RESTful web services, that's what the people will call. It is a huge concept. I will not go over in detail about these concepts. I believe that you already know about the REST API or the RESTful web services, but I will give you a general definition or the simple example to understand about the RESTful web services or the REST API. So basically REST API, which is nothing but a collection of URLs which is available on the server. So we have a group of URLs and those URLs will be available on the internet. And each URL, call it as a REST endpoint. So each URL we are going to call it as a REST endpoint in technical terms, and each REST endpoint performs a certain operation, maybe fetching the nodes from the database or creating a nodes or deleting the nodes. It could be anything, but each URL performs a certain operation, and each REST endpoint also contains a HTTP method. So you already know that HTTP methods, probably there are 7 or 8 HTTP methods are available, out of which 4 are the most popularly used HTTP methods, which is get, which is used to fetch the data from the server, post, which is used to create the data in the server, put, which is used to update the data in the server, and delete, which is used to delete from the server. And for HTTP post and put methods, we are going to pass the data in the request body. So we have a request body and the response body. So if you want to send any data to the server, we are going to pass it inside the request body, and HTTP post and put methods will support the request body, whereas the response body contains the response data coming from the HTTP response or from the server. So what is the data format that we are going to use to exchange the information between the client and server? So we are going to use the JSON data format to communicate with the REST API. JSON is the most widely used data format, and we can also use other data formats like XML, text, but out of which JSON is the most commonly and widely used data format. We are going to send the JSON data in the request body, and it will return the JSON response in the response body. So what is JSON? JSON stands for JavaScript Object Notation. It contains key value pairs. Just like in Java, the hash map and the map contains the key value pairs. Similarly, the JSON also contains the key value pairs. But here the key will always be in a string, but the value could be anything. The value could be string, number, boolean, or even it could be object. So here is just an example for the JSON data format. You can see the key, which is always be in a string, and the value, it could be string, it could be number, or it could be object or anything. So how to map the JSON data to a Java objects, because we are working with a Java application and we are sending the data in the JSON format. How the JSON data is going to map with the Java objects? So this is with the help of the Json API. So the Json API will take care of everything. It is going to map the JSON data with the Java objects. In order to work the Json API correctly, we should use the same property name on both the sides. So while sending the JSON data to the server, we should, whatever the property name we have used, the same property names we should use in our Java objects to map the JSON object with the Java objects. That's how it will work. So let's look at the application architecture. So before we start writing the code, we should always understand the application architecture. So we have a client and a server, and inside the server our application will be running, and our application is going to divide it into multiple layers. So we have a presentation layer and the service layer and the repository layer, or also called as DAO layer. So when a client sends a request, let's say /nodes, and the server takes that request and send it to the controller. So the controller is going to handle all the HTTP requests. It is going to take that request and it's going to map the HTTP URI with the controller methods, and each handler method is mapped to a URI. Once the URI matches, a respective method will be executed, and inside the controller we are going to call the service method for extra information, and the service layer is going to call the repository layer or the DAO layer for the database operations, and the repository layer, it is going to interact with the database for the CRUD operations like create, read, update and delete. And again, the repository will send the information back to the service layer. The service layer will send the information back to the controller layer, and the controller layer, it's the responsibility of the controller layer to prepare the data in which the user is expected, and it will send it back to the client as a HTTP response. So this is the whole idea of the application architecture, and this is called a 3-layer architecture. Alright, now we have understand the application architecture, and we have understood about the REST API and the JSON data format and other informations. And in the next video we are going to create the Spring Boot application, and we are going to start building our REST API step by step. I will see you in the next video. Hi, welcome back to the course. In this video we are going to create the Spring Boot project, and we are going to import it in the STS IDE. So there are a couple of ways to create the Spring Boot project. The one way is using the STS IDE, and the another way is using the Spring Initializer. I will show you both the ways. You can use any one of the way to create the Spring Boot project. So the first way is using the STS IDE. So in case if you have installed the STS IDE, you can create the Spring Boot project inside the STS IDE. If you're opening the STS IDE for the first time, then in the left hand side of the IDE you can see the quick actions options, and in that you can select the second link, which is create new Spring Starter project. In case if you have already created a few projects, in order to create the new project you can go to the file and go to the new and select Spring Starter project. The service URL, which is start.spring.io. The project name I'm going to call Spring REST API. I'll use the default location. Type Maven, packaging jar, you can also choose var. The Java version, I have installed Java 8. Language Java. The group ID in.bhushan Sirigur. Artifact ID Spring REST API. The version, I'm not going to touch this. Description Spring Boot REST API. Packaging in.bhushan Sirigur dot Spring REST API. Click next. Alright, let's go back. Okay, when you click on this next, this is the screen that you will see. We need to choose the dependencies. Before that, we need to choose the Spring Boot version. At the time of this recording, the latest and stable version of Spring Boot is 2.5.0. We also have other options, which is the snapshot versions, and these are not the stable versions. Make sure to choose the latest and stable versions. And here we are going to select the dependencies. So for now we are going to use a single dependency, which is the web dependency. Since we are creating the RESTful web services, we are going to add this dependency. Later we are going to add a few more dependency as we progress in the course. Select the Spring Web and click finish. So this is going to take a couple of minutes to download all the dependencies to your project. Once it download all the dependencies, go ahead and open the project, and this is the typical Spring Boot project structure. Inside the source main Java we have the base package, and inside this base package we have a main class which contains the main method. And we also have the source main resources. Inside this we have the property file. Later we are going to configure the data source inside this application.properties file. We are not going to touch the static folder and the templates folder. In case if we are using any template engines, then we are going to add those templates inside the templates folder like ThimeLeaf or JSP, any other template engines. Static, which contains the static files like the JavaScript files, CSS files, or any other images. Alright, so now we have seen how to create the Spring Boot project with the help of STS IDE. Now let's see how you can create the Spring Boot project using the Spring Initializer. In case if you are using Eclipse IDE or the IntelliJ IDEA, then you can use Spring Initializer to create the Spring Boot project. So in order to do that, let's open the browser and search for start.spring.io. This is the official page for creating the Spring Boot project, but unfortunately the website is not up. There might be a problem with the website. Let's actually go ahead and reload this. Now the website is up. Alright, this is the official website for creating the Spring Boot applications, which is the Spring Initializer. And by the time of you are watching this video, the UI might look different or the UI might be same, because the Spring team keep on updating the website. But as far as the options, it looks similar, but you might seeing the UI changes sometimes in the website. Alright, so let's go ahead and select the options, which is the project, Maven project, language, Java, and the Spring Boot version. I will choose 2.5.0, which is the latest and stable version. The group ID I will call n.bhushan sirgur. Artifact ID Spring test. The name Spring test. Description Spring demo app. Packaging n.bhushan sirgur dot spring test, and the packaging jar, the Java version 8 which have been installed. And here we are going to add the dependencies. As of now we are going to add a single dependency, which is the web dependency. You can just search for the dependencies inside this search bar. It will pop up the dependencies. So let's go ahead and select the Spring Web, and once you are happy with that, you can, before downloading the project, you can see the project structure. You can click on this explore and you can see this is the project structure. We have the git ignore, Maven, help.md, pom.xml, and the source. Inside the source we have a source main Java and the main class as well. Okay, so once you are happy with that, you can just go ahead and click on this download, or you can click on this generate to download the starter project. I will click on this. This is going to download the project in a zip file, and let's go ahead and open this. Let me extract this. Let me delete the zip file, and now we are going to open this inside the Spring tool suite, or you can open this inside the Eclipse IDE or the IntelliJ IDEA. So to open the existing project, you can click on this file and go to import, and you can filter for Maven and select the existing Maven projects. Click next, click on browse and go to the downloads and select the project and click open. It will direct the pom.xml file, and click finish. This will also download the dependencies, and it will take a couple of minutes depending upon your internet speed. Once it download all the dependencies, you can expand the project and you can see the same project structure which we have created earlier. Okay, the typical Spring Boot project structure, and inside the source main Java we have the main class. Alright, so now we have created the Spring Boot application in two different ways, by using the STS IDE and using the Spring Initializer. In the next video we are going to create the controller and services, and we are going to create our very first REST endpoint. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to create the controller and we are going to create our very first REST endpoint. Let's begin. So before that, I'm going to close all the files just to keep it simple. And I'm going to close the other project which we have created using the Spring Initializer. Okay, so now we are working on the Spring REST API project. So let's expand this. And inside this source main Java, we are going to create a new package. Just like we have discussed in our application architecture, we are going to divide our application into multiple layers. And to organize our application, just like the production application, we are going to create a few packages. So the first package we are going to create is the controller package. So right click on the base package and choose package. And let's call controller. So this package contains all the controller classes, and inside this we are going to add a new controller. So we're going to create a new class and I'm going to call this employee controller and click finish. Let me expand this. Alright, so now we have created the Java class. So in order to convert this class into a controller, we are going to add a single annotation, which is the @controller annotation. So let me import this annotation. So by adding this @controller annotation, now this class is responsible for handling the HTTP request, which means the server will send the HTTP request to this class. Not only this class, if you create any class and that class is annotated with the @controller annotation, then the server will send all the HTTP requests to these classes. So now inside this we are going to create the handler methods. Public string, I'm going to call this get employees. So this handler method will return a string. So let me return a string which is displaying the list of employees. Alright, now we have created this handler method. So as we discussed, inside the controller, every handler method is mapped to a URI. When the user sends a HTTP request, let's say localhost :8080/employees, so this /employees, which is nothing but the URI, and this URI we are going to map it to the handler methods. So now let's map this URI to this handler method, which is get employees. So in order to map this, we are going to use an annotation called @request mapping, followed by the URI /employees. So we also discussed that every URL contains the HTTP method, which is a get or a post or put or delete. Similarly, we also need to specify the HTTP method in which this handler method is mapped to. So the way to specify the HTTP method is by using the method attribute, and we are going to use the HTTP method which is get. So when the user sends a HTTP GET request to the /employees, then the server sends that request to this controller, which is the employee controller, and it is going to map it to the get employees handler method, because the get employees method is mapped to the /employees. So this /employees and this /employees will match, and it also looks for the HTTP method, since this will be a get request and this also contains the HTTP get method, and this get employees method will be executed, and it is going to return the displaying the list of employees text. So let me import the @request mapping annotation, and let me get rid of this comment. Alright, so now we have created the controller and we have created the handler method, and handler method is mapped to the URI. So let me import the HTTP method as well. Alright, this is not HTTP method and this is request method. Alright, so let's import this request method. Alright, so now we have created the handler method and it is mapped to the /employees URI. But since we are dealing with the RESTful web services, every time when we make a HTTP request, we should expect the HTTP response. Okay, so in order to return the HTTP response from this method, we are going to use annotation called @responseBody annotation. So let me import this @responseBody annotation. So this is going to return the displaying the list of employees inside the HTTP response body. So that's why we are going to use @responseBody annotation. If we are not creating the RESTful web services, then we don't need to use this @responseBody annotation. We are going to return the template engines like which we have used in our application. We are going to return the data to the template engines. But since we are dealing with the RESTful web services, we are going to annotate this method with the @responseBody annotation. Not only this method, we are going to annotate every method with the @responseBody annotation. Alright, so now we have created this method. So let's go ahead and run our application and see what do we get. So let me save this file, and now let's go to the main class. Let me start the application. You can click on this plus button and choose the Spring Boot application and click OK. This will start the Spring Boot application and it will start in the port 8080, localhost 8080. So you can see the application has been started running on the port localhost 8080. Let's navigate to the browser and open a new tab. Go to the URL which is localhost:8080/employees. We should see the message displaying the list of employees. Alright, now we have created our very first REST endpoint, which is /employees. Okay, so let me go back to our STS IDE and let's open the employee controller. Okay, so now we have annotated this employee controller with the @controller annotation, and we have annotated our handler method with the @requestMapping annotation and the @responseBody annotation. But if you look at this, we are using 3 annotations just to create one single REST endpoint. We can even reduce this by adding a few other annotations which will eventually use these annotations internally. So which means instead of using the @controller annotation, we can use @RESTController annotation. So let me comment that I will use @RESTController annotation. Let me import this. So this is nothing but the combination of @controller annotation plus @responseBody annotation. So if we use @RESTController annotation, then we don't need to use the @responseBody annotation on every handler methods. Okay, so we don't need to use this @responseBody annotation. We can get rid of this. Okay, you can see now we have just a single two other annotations, which is a @RESTController annotation and @requestMapping annotation. Okay, so remember that @RESTController annotation is a combination of @controller annotation as well as the @responseBody annotation. So let me get rid of this. Let me save this. Okay, so now let's come back to this handler method. So we have annotated this handler method with the @requestMapping annotation. This will take 2 options, which is the value and the method, and the request method is get. So the Spring also provides a handful annotations if we are using the get method, post method, put method, or delete methods. If you are for every HTTP methods, there is a annotation, so we can use those annotations to map the handler methods. Since here we are dealing with the HTTP GET method, we can use @get mapping annotation followed by the URI, which is /employees. So now we don't need this above one. So let me comment this. Let me import the @get mapping annotation. Similarly, we have @post mapping annotation, @put mapping annotation, @delete mapping annotations. For every HTTP method, there is an annotation. We can use those annotations to map the handler methods. Alright, so now let's save this and let me stop the server. And let's restart the application again. Alright, the application is started. Let's navigate to the browser and let's go ahead and /employees. When we hit enter, we should see the same response, which is displaying the list of employees. Alright, now we have created our very first REST endpoint, and we have seen a couple of annotations, which is @controller annotation, @rest controller annotation, @request mapping annotation, and @get mapping annotations. I hope you enjoyed this video. In the next video, we are going to create other REST endpoints to perform the database CRUD operations. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to add a few other dependencies to our existing application. So let's begin. So once you created the Spring Boot project, in case if you want to add the other dependencies to our existing Spring Boot project, you can do that as well. There are two different ways to do that. I will show you both the ways. So the first way is by adding the Spring Boot starters. So in case if you are using the STS IDE, you can right click on the project and you can choose the Spring, and then you can add starters. Okay, so again we are going to add the dependencies which we want to add to our application. So I'm going to add the dev tools. So inside the developer tools, we have a Spring Boot dev tools. If you hover on this option, you can see the description of this dependency. It provides the fast application restarts, live reload, and configurations for enhanced development experience. So by adding this dependency, we don't need to stop the server and restart the application again when we make any changes. Okay, it will automatically, the dev tools will restart our application. That's the use of dev tools. Let's check this and click next. It will show you the two different files. One is the source file and the changes file, the ones we have made the changes. So just click on this pom.xml and click finish. Okay, the dependency will be added to the pom.xml. You can verify that. Go to the pom.xml, and if you scroll down, you can see a new dependency has been added to our application, which is the dev tools. Okay, so this is the one way in case if you are using the Spring tool suite. Other ways by going to the Spring Initializer. So let's go to the browser and go to the Spring Initializer and click on the add dependencies, and we are going to add one more dependency, which is the Lombok dependency. Just search for the dependency and click on this. Now we have added the Lombok dependency as well. Just click on this explore and go to the pom.xml, and if you scroll down, you will see the dependency. Just copy this dependency and now go back to the STS IDE or the IDE which you are using for the application development, and go to the pom.xml, and inside the dependencies section, just paste the dependency which you have copied and format the code. Command Shift F, which is on Mac, Control Shift F, which is on Windows, and let's save the file. So this Lombok dependency is nothing but the Java library. It's a Java library dependency. Using this dependency, we don't need to create the setters, getters, and equals method and other toString methods inside our model classes or the Pojo classes. Okay, it will provide the annotations like @getter, @setters, @data annotations. Using that, we can completely remove those boilerplate code. That's the purpose of using this Lombok annotation. Alright, so now I will close this pom.xml, and I'm going to keep these two files as it is. Alright, so now we have seen how to add the dependencies to the existing Spring Boot application, and in the next video we're going to create other REST endpoints. I will see you in the next video. Hi, welcome back to the course. In this video we're going to discuss how to pass data from client to server. So there are some situations where we need to get a single record from the database, or we need to delete a single record from the database. So for that we need to send information to the server, like the employee ID or the customer ID or the note ID. Anything we need to send information from client to server. We are going to use two different techniques or two different ways. The first way is by using the path variable, and the second way by using the request param. So we are going to discuss both the ways, and in this video we are going to discuss by using the path variable. Let's begin. So I'm going to create a new handler method, public. This is going to return string and get employee, not employees. We're going to get a single employee by passing the employee ID, and we are going to map it to the URI, which is at get mapping, because this is a HTTP get method / employees. So in order to pass a data or the ID from client to server, inside the URI we are going to create a variable. This variable is called it as path variable. So in order to create the variable, after the slash we are going to open the curly braces, and inside these curly braces we are going to provide the variable name. I will call ID. You can give any name you want. So now our path URI would be localhost :8080 /employees / the user will provide the ID, the employee ID, which is 8, 10, 9 something, any number he can pass. The employee ID he will pass. Let's assume that it's 12. Okay, so now when the user sends a HTTP GET request to this URL, then this handler method is going to execute. So now we are created the variable inside the URI. Now we need to receive this inside our get employee method. So for that, inside our method parameter or the argument, we are going to use an annotation called @path variable. And we need to specify the variable name which we are going to receive. In our case it's ID, and we need to provide the data type and the variable name. So this is a long, and the parameter name which is ID, or the variable name which is ID. So let's import the @path variable annotation, and now we are going to return a text which is fetching the employee details for the ID. We are going to concatenate the ID. Alright, so now we have created this handler method, and we have mapped it to the URI, which is /employees / the employee ID, and we are going to receive that employee ID using the @path variable annotation. Okay, so let me get rid of these comments, and I'm going to remove this as well. Okay, let's save this, and let's go to the main class, and let's start our application. Alright, it is failed to start. The port 8080 is already in use. Okay, no worries. Let me restart it again. From next time onwards we don't need to restart the application, because we have already added the dev tools. I simply stopped the server. There is no need to stop the server at all. Alright, so now let's switch to the browser, and let's go to the localhost :8080 /employees, and we will pass the employee ID, which is 2. When we hit enter, we should see the message fetching the employee details for the ID 2. Let's change this to 78, hit enter, we should see the message fetching the employee details for the ID 78. Alright, so we have learned the first way of passing the data from client to server using the path variable. In the next video, we are going to discuss the other way, which is by using the request param. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to discuss the other way of sending the information or sending the data from client to server. Let's begin. So in some of the website, you might have seen in the URL there will be a question mark, and after the question mark there is a text is equal to and some value will be there. This is nothing but the request params or the query params. Okay, so after the question mark, anything that comes in, that is nothing but the query params. We are going to send that information from client to the server. It contains the key value pairs, the key which is nothing but the variable name, and the value which is nothing but the value of the variable. And you can also pass multiple query params by separated with ampersand symbol. So user is equal to 34 and my name is equal to Bhushan. So like this you can send any number of values or the parameters inside the URL separated with ampersand symbol. Let's see how we can access these variables inside our handler methods. So let's go back to the STS and let's go ahead and create a new handler method, public string delete employee, and we are going to map this to the at delete mapping annotation. We are going to make the delete request at delete mapping, and we are going to map it to the /employees. If you want to use path variable, then you can use the curly braces and you can create the variable. Since we are dealing with the request params, then we don't need to specify that inside the URL. All we need to do is inside our method parameter or inside the method argument, we are going to make use of the at request param annotation, at request param annotation, and we are going to provide the followed by the variable name, which is nothing but the ID, and we are going to provide the variable name and the data type, which is long and ID. Let's import the at request param annotation and also the at get mapping annotation, and now inside this we are going to return a text deleting the employee details. For the ID, we are going to concatenate the employee ID. So let's save this. So now if the user sends a request localhost :8080/employees (ID is equal to 34, then this handler method will be executed. This ID is nothing but the variable name that we are receiving using the at request param annotation, and the parameter data type which is long, and the variable name which is ID. So let's save this. Application is restarted. It is running on the port 8080. So since this is a delete request, we cannot test this REST endpoint inside our browser. The browser supports only the GET request. So in order to test this REST endpoint, we are going to use the REST client, which is the Postman. So inside the Postman, let's open a tab and let's change this to delete, and let's provide the URL which is localhost :8080/employees (ID is equal to 78), and when I click on this send, we should see the response deleting the employee details for the ID 78. Let's change this to 100 and click send. We should see the message deleting the employee details for the ID 100. Alright, now let's switch to the STS IDE. Let me remove these comments. So now if the parameter name is ID and inside the method parameter if you are using the same variable name, then you don't need to specify this inside the @request param. Okay, basically inside the URL which the variable name and the method argument variable name both are same, then you don't need to specify this. Similarly inside the path variable as well. So if the variable name which is present in the URI and the one which is present in the method argument both are same, then you don't need to specify this ID. You can remove that. So now let's save this. Let's test our work. Let's switch to the Postman, and first let's change this to 200 and click send. It should work how it was working before, deleting the employee details for the ID 200. Let's test it for get localhost 8080/employees/45. Hit enter or click send. We should see the message fetching the employee details for the ID 45. Alright, so now we have discussed the two different ways of sending the data from client to server, and in the next video we are going to discuss more about this Postman, how we can organize our REST APIs inside this Postman. I will see you in the next video. Hi, welcome back to the course. In this video we are going to organize our REST endpoints inside our Postman. Let's begin. So inside the Postman we can create the collections, and the collections contains the REST endpoints. So this way we can organize our application or the REST APIs nicely. So I have created a few collections like Expense Tracker API, React Notes API. Okay, and if you open these collections, you can see we have a bunch of REST endpoints. So at any point of time I can go ahead and click send and it will automatically runs. Okay, so like this we are going to create a new collections and we are going to keep all our REST endpoints inside the collection. Let's begin. So first let's go ahead and create a new collection. Just click on this new and it will ask you to what you need to create. I'm going to create a new collection. Click on this collection and you can provide the collection name. I will say Spring Boot REST API YouTube. Hit enter. So now we have created a new collection. So inside this collection we are going to create a new request. So click on this add request and you can provide the request name. So far we have created 3 REST endpoints. So one is fetching the list of employees. So I'll say read employees, and inside this we are going to select the option which is the get request, and this is the URL which is localhost:8080/employees, and you can click on this save to save the collection. So now we have the read employees. So you can test this. Click on this send. We should see the message displaying the list of employees. Similarly we are going to add 2 other requests. So you can just click on this and you can click on this add request. Click on this pencil icon and provide the request name which is read employee, and this will be a HTTP GET method, and localhost:8080/employees/ the employee ID which is 34, and when I click on this send we should get the response fetching the employee details for the ID 34. You can click on this save, and let's go ahead and add up one more request. The request name, which is delete employee, and this will be delete HTTP method localhost :8080/employees (ID is equal to 78), and when I click on this send, we should see the response deleting the employee details for the ID 78. Let's save this. Alright, so now we have created the collection, and inside the collection we have added the HTTP request. So we have read employees, read employee, and delete employee. Alright, so now if you look at these URLs, inside this we have hard coded the host name. The localhost :8080 is the host name. We can, instead of hard coding this, we can also create a variables inside the Postman, and we can map it. This will help us when we are testing in a different environments. Okay, so for the different environments we can create a different variables, and then we can switch the environments, and then we can just test it. Let's see how we can create the variables inside the Postman. So let's go to the you can see this no environment in your Postman at the very top right hand side. You can click on this, and I have created a few environment variables. Okay, the Nodes API dev environment, Nodes API prod, and the task manager API dev, task manager API prod. Okay, so in order to create the environment variables, just click on this plus I icon, and you can click on this environment add button. We're going to create a new environment, which is Spring Boot API YouTube, and this will be the dev environment, and inside this we are going to create the variable which is URL, and we can provide the initial value, but I'll just give the current value because there is no initial value as of now. So the current value, which is localhost :8080, this is our current value. So now go ahead and save this. So now if you click on this drop down, you can see a new environment which is Spring Boot API dev environment. Okay, so let's click on this. So now we are inside this environment. So now if you go to the read employees, instead of hard coding this, we can use the variable which is URL. So in order to use that variable, we are going to use two curly braces, and inside that we are going to provide the variable name which is URL. Now if you hover on this variable name, you can see the initial value, there is nothing, the current value, localhost :8080, scope, environment. Okay, so now let's save this, and when I click on this send, still we do get the message displaying the list of employees. Similarly, we can go ahead and change for rest of the request. So let me change this to URL, save this, and for the delete request, let me get rid of this. Let's use the variable URL. So let's save this. So you can test it. So instead of this 78, let's pass 7 and click on this send. We do get the message deleting the employee details for the ID 7. Alright, let's save this. So now we have created the collection, and we have also created the environment variables. Once we deployed our application to the production, we are going to create one more environment variable which is the production variable, and we're going to map it to that. Alright, that's all about this video. In the next video, we're going to create other REST endpoints for HTTP put method and HTTP post method. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to see how we can map the JSON data to the Java objects. Let's begin. So first, let's go ahead and create the Java model class, because we need to map the JSON data to the model class. So let's open the project, and inside the source main Java, I'm going to create a new package, just like how we have created the controller package. and I'm going to call this model, and inside this I'm going to create a new model class which is employee, and inside this I'm going to create a private fields, private string name, private long age, private string location, private string email, private string department. I'm not going to generate the setters and getters. Instead, we are going to use the Lombok annotations. If you remember, we have added the Lombok annotations inside our pom.xml, which will help us to reduce all the boilerplate code. So I'm going to add a few annotations, which is setter and getter and @toString. So let's go ahead and import these annotations. So now we have included the @setter, @getter, @toString. So you can see the setters and getters. Let's type Command O in Mac or Control O, and you can see now we all have the methods, the set name, set age, set location, set email. Okay, so with this annotations we now have generated the setters and getters, toString method, and yeah, that's it. Now let's save this, and now let's go to the employee controller, and let's go ahead and create a new handler method, public. This is going to return string and save employee, which is our handler method name, and we are going to annotate this with the @post mapping annotation, because this is going to map it with the HTTP post method, post mapping followed by the URI, which is /employee or employees. Okay, so we can also create a same URIs inside the controller, but the methods, HTTP methods, should be different. So we also have this /employees, which is a get mapping, and also we have a /employees, which is a post mapping. So when we make a post request for the employees, this handler method will be executed. When we make a HTTP get request for the /employees, this method will be executed. So for now, let's go ahead and import this @post mapping annotation, and now we are going to just return a string, which is saving the employee details to the database. So now what we can do is, the user or the client will send the employee's information inside the request body. If you recollect, we have discussed the HTTP post and put method will support the request body. So inside the request body, we are going to send the employee information or the employee details, and we are going to receive that information inside this handler method. So in order to receive that information, we are going to use annotation called @request_body, and we are going to use the model class, which is employee, and I'm going to call this employee. Let's import the employee. Just go ahead and print the employee. I'm going to concatenate the employee. Let's save this. So now we have created the handler method, which is mapped to the /employees, which is of the HTTP post method, and this will receive the employee details. Alright, so now let's go ahead and test our work. So I will go to the main class, and I'll just click on this run button. Alright, the application is started and running on the port 8080. Let's navigate to the browser. Navigate to the URL, localhost. Okay, I'm sorry, this is actually the post request. We need to use the Postman. Let's go to the Postman and let's create a new request, add request, and this will be create employee, and the URL, which will be post method localhost, not localhost. We have created an environment variable. We are going to use URL / employees. And now if you go to the body section, inside the body we are going to choose raw, and then in this drop down we are going to select the JSON. We are going to send the JSON data. So as we discussed earlier, we have to use the same property names on both the sides. So if I go to the STS, inside our employee we have created the field names, which is name, age, location, email and department. We need to use these field names inside our request body in order to map the Json API with this employee model class. So let's go ahead and use this. So what I'll do is I'll just go ahead and copy this and I'll paste it inside this. So we don't need this private. I'll just wrap this within the double quotes. Name, which is Bhushan, let's wrap this age inside the double quotes, and the age, it will be in the number format, and I am 28, and then location, which is of type string, and I am from India, and then email address, let's wrap this also inside the double quotes, and my email address is bhushan@gmail.com, and the department, I am an IT guy, so let me type IT, and now we are going to wrap this also inside the double quotes. Alright, so now we are passing this information inside the request body. All we need to do is click on this send button, and we should get the response saving the employee details to the database. Employee name is equal to Bhushan, age 28, location India, email address bhushan@gmail.com, and department IT. Alright, in this video we have learned how to map the JSON data to the Java object, and in the next video we are going to create a last handler method for the updating the employee data. Then we are going to connect our application to the database using the JPA. That's it for this video. I will see you in the next video. Hello, welcome back to the course. In this video we are going to see how we can make the update request or the put request. So let's begin. So inside the Postman I am going to create a new request. Go ahead and create a new request, and I'm going to call this update employee, and the URI, the HTTP method, which is a put method, and the URI within the two curly braces we are going to use the environment variable /employees/ in order to update the employee we need to pass the employee ID. This time we are going to make use of the path variable. So let's pass the employee ID, let's say 45. So now we have the URI, and inside the create employee I'm just going to copy this, and inside the update employee go to the body and choose raw, and from the drop down select JSON, and let's paste it. And now let's go to the STS. Let's create a new handler method for updating the employee data, public, and this time we are going to return an employee object itself, and the handler method name, which is update employee, and we are going to map it to the @put mapping annotation, and the URI, which is /employees/ we are going to make use of the path variable. So within the curly braces we are going to create the variable name, in this case it's ID, and within the method parameter we are going to receive that ID using the @path variable annotation, And since we are going to make use of the same variable name inside the method parameter, then we don't need to specify the id name within the path variable. So all I need to do is enter the data type, which is long, and the variable name, which is id. Now inside this we are just going to return, and also we need to receive the employee object because we are going to send the information inside our request body. So let's use @request body. We are going to map it to the employee object, employee, and now inside this we are going to return the employee object. And before that, just for our understanding, we are going to print a message which is updating the employee data for the id, which is the id which we are receiving from the URI. So let's import the @put mapping annotation. Alright, now let's save this, and our application is already running and it has been restarted. Now let's go to the Postman. Let me clear the console, and now let's go to the Postman, and when I click on this send, we do get the response, which is the employee data, because we are returning the employee data, and since it is the response is giving in the JSON format, because we have added the @rest controller annotation that itself includes the @response body annotation. Alright, so now let's go to the STS, and you can see the message, console message, which is updating the employee data for the ID 45. Alright, so now we have created a 5 handler methods. Later we are going to perform the database operations with the help of these handler methods. Alright, that's all about this video. I will see you in the next video. Hello, welcome back to the course. In this video we are going to see how we can read the property file values inside our controllers. Let's begin. So assume that first of all I'm going to close the files. We don't need all these files. I'm going to keep the employee controller open. So now let's go to the project explorer and let's open the application or properties file. So this is a property file. So inside this we are going to configure the data source and other configuration properties. Let's say for some reason we want to read this property in our controller classes. So we can easily do that using @value annotation. So let's assume that this application or properties file contains the key value pairs. Let's say app.name is equal to the app name. In this case it's employee management system, employee management application. Okay, similarly we can create any number of properties. So let's say app.version is equal to v1. Okay, so now let's save this, and inside the application, the employee controller, we are going to read that values. So the way to read that property is by using the @value annotation. So this @value annotation contains variables or the property names. In order to access those properties we need to use $ and the curly braces and then the property names. So we have to specify the key names, which is app.name, and then we need to map it to the variable. So private string, we are going to map it to the app name, and similarly we are going to copy this and let's paste it in the down app.version, and this will be app version. So let's import the @value annotation, which is from the org.spring framework beans factory.annotation.value, not from the Lombok value. Now let's go ahead and create a new handler method. This will return the application name and the version, public string, and get app details. We are going to map this to the URI, which is get mapping and slash version, and this is going to return just the application name, which is app name, and then we are going to concatenate a string which is hyphen and the app version, Alright, now let's save this, and the application is restarted. Let's go to the browser, or we can go to the Postman, and now let's go ahead and create a new request. Add request. This is app details. This is a get request, and we're going to make use of the environment variable, which is slash URL slash, we need to use the version, and when I click on this send, we do get the details, which is employee management application minus v1. So we can read the application properties values using the @value annotation. So we can also give a default values to this. Let's say inside our application properties, I'm going to comment these two, and now if we run our application, we will run into an error. Let me show that, and when I save this, you can see the console, we do get an error because we have not created any properties, but we are trying to access the properties, which is app name and app version. That's why we are getting that error. So to avoid that, what we can do is we can provide the default values. So just after this app.name, you can provide the colon, and you can provide the default values, which is employee tracker, and the version, which is version 1. So let's save this, and if you take a look at the console, this time we do not run into any errors. And when I go back to the Postman, when I click on this send again, we do get the default values, which is employee tracker and version 1. Alright, this is all about the @value annotation. I hope you understand how to read the property file information or the properties inside the controllers. That's all about this video. I will see you in the next video. Hello, welcome back to the course. In this video, I will show you how to change the port in Spring Boot application. By default, when we run the application, the server will takes the port number as 8080. That will be the default port. For some reasons, if you want to change the port number, you can definitely do that by adding a property inside the property file. So let's see how we can change that. Before that, what I'll do is I'm going to remove these default values, and let's save this. Now let's go to the application.properties. Let's enable these two properties, and now in order to change the port number, all we need to do is first let's stop our server, and we're going to make use of the property, which is server.port. Okay, and you can specify the port number. Let's say 9090 instead of 8080. Let's use 9090. Let's save this, and now let's run our application. Alright, our application is started. Let's see the port on which it is running. It is running on the port 9090. Let's go to the browser and let's make a get request. I don't use Postman because in our Postman, in our environment variables, we have already configured it to 8080. So let's use the browser just for the testing, which is localhost :8080, and which is /employees. Instead of that, we can check for the /version, hit enter. Sorry, it's not 8080, it's 9090/version. Hit enter. We should see the version, which is employee management application -v1. So this is how you can change the port number using the server.port property. Alright, that's all about this video. In the next video, we are going to see how to build our Spring Boot application and how to run the jar file using the command prompt. I will see you in the next video. Hello, welcome back to the course. In this video, we are going to build our Spring Boot application and we are going to create the executable jar so that we can execute that jar file using the Java command anywhere on our application, on our system. So let's see how we can build the application and create the executable jar. So let's go ahead and stop the server. And now right click on the project, choose run as, choose Maven build, and inside the goals enter clean install and click apply, click run. This is going to build our project and it is going to generate the executable jar inside the target folder. Let me expand this. So this will take a couple of minutes or a couple of seconds depending upon your internet speed. Alright, you can see the message build success. So now let's go to the project explorer and let me refresh this. And if you go to the target folder inside this, you can see a jar file has been created. So now let's go ahead and open this inside the command prompt, and I have already, let me open the command prompt. I'm inside the Mac, so I'll use terminal. If you are on the Windows, you can use the command prompt. I will navigate to the project where I have created CD documents, and inside the CD I have a YouTube projects, and inside this we have the Spring REST API. So Spring REST API, and inside this we have a target folder, CD target, and inside this we have the jar file. So let's execute java -jar and the file name, which is Spring REST API -0.0.1 snapshot.jar. and before that let me close this, and if I open the application.properties, you can see the port number is server.port is 9090. Okay, so when we execute the command, the application will be running on the port 9090. So let's go ahead and hit enter. You can see the application is started and it will be running on the port 9090. So let's go to the browser and let's navigate to the URL, which is localhost 9090/version. Hit enter. We should see the message employee management application v1. We can also try for /employees. You can see displaying the list of employees. Alright, this way we can build our Spring Boot application and create the executable jar, and we can run that jar file anywhere within our application, within our system. Alright, that's all about this video. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to discuss about the two most important properties, which is JSON property and the JSON ignore property from the Json API. These are the most important properties that we are going to use in our production grade applications. So let's discuss about these two properties in detail. So before that, I would like to go to the application.properties and I'm going to remove the server.port. We don't need that. So the default port is 8080. So our application has restarted. So now let's go to the Postman. Let's test our work. So when I click on this send, I'm inside the update employee request. When I click on this send, we do get the response. So if you look at this response, we are getting the HTTP response as name, age, location, email and department. Let's assume that for some reasons I don't want to return the HTTP response, the age property inside the HTTP response. So how to do that? For example, when we are working with the production grade applications, we do have the user object. The user object contains the email address and password, and we don't want to return that password to the HTTP response because the password is a sensitive information. How we can do that? So we can easily do that by adding the JSON ignore property inside our model class. So let's see how we can do that. Let's go to the STS, and inside the, let me close this application properties, and let's go to the employee.java. So inside this, let's say we don't want to return the age to the HTTP response. We can easily do that by adding the @JSON ignore property. So let's import this. So now we have added the @JSON ignore property to the age field. So let's save this, and the application is restarted. Let's navigate to the Postman, and we are sending the information name, age, location, email and department. But when I click on this send, inside the HTTP response we do get the name, location, email and department. We are not seeing the age inside the HTTP response. This is a very useful feature. So when we are working with the production grade applications, we should not, if you want to hide the sensitive information from the HTTP response, we can use the JSON ignore property. So other property that we're going to talk about is the @JSON property. Let's say for some reasons I do want to give a different name to this name property. So we can easily do that by adding the @JSON property. So @JSON property, and we can provide the alias name or the alternate name, which is full name. So let's import this JSON property. So now we can, from the payload in the HTTP request body, we can provide full underscore name and the value, and that will map it to the name property inside our model class. So let's save this. Let's go to the Postman, and inside this I'm going to change this to full name, and when I click on this send, we do get the response, location, email, department, full underscore name. So we are sending the property name as full underscore name, and that is going to map it to the name property inside our model class with the help of the @JSON property. So anytime if you want to provide an alternate name or the alias name, you can easily do that by using the @JSON property annotation. Alright, so now I'm going to remove these two annotations. We don't need that. I have just showed you these two features for the learning purpose. Alright, let me remove unused imports. Alright, so now we are in a clean slate. We have a name, age, location, email and department. So let's save this, and in the next video we are going to discuss about the other features. So I will see you in the next video. Hello, welcome back to the course. In this video we are going to create a service class, and we are going to return the list of employees. Let's begin. So first of all, I'll go ahead and open the Project Explorer, and inside this, just like how we have created the controller package and the model package, we are going to create one more package, which is the service package. I'm going to call this service, and inside this I'm going to create a new interface. I'm going to call this employee service, and inside this I'm going to create a new method, which is list of employees. This is going to return a list of employee, and I'm going to call this get employees. So let's import the list as well as the employee. Alright, so now let's save this, and now let's go ahead and create the implementation class. So inside the same package, I'm going to create a new class, which is employee service implementation. I'm going to call it as IMPL in short. This is going to extend the interface, which is employee service. Click finish, and we do get the method which is the get employees. Let me get rid of these comments, and what I'll do is, first of all, I'm going to annotate this with the @service annotation. That will make us this class as the service class. So let's import the @service annotation. So now inside this, I'm going to create a static block, and inside this I'm going to create an employee object. Employee E is equal to new employee, and I'll quickly add a few properties. So alright, so now we have this employee object, and I'm going to add this to the list. So at the top I'm going to create a static list which is private static list of employee list is equal to new array list. And now inside this I'm going to add this employee to the list. So let me import the array list. Alright, so now we have a list, and I'm going to return this list inside the get employees. So return list. Alright, so if you want, you can add one more employee object. So let's actually copy this and paste it. Let's quickly change this to Bharat. He is 32 years old and he is in textile department, and his email address is bharat@gmail.com, and he is from Australia. Okay, so now let's save this. So now we are returning that list, and inside the employee controller what we can do is we can auto wire the employee service. So let's quickly auto wire this. So private employee service, I'm going to call this e-service in short. Let's actually auto wire. So we can use setter injection, but I'm going to use the auto wire annotation because that is very easy. Alright, so we have imported the @AutoWire annotation, and we have this employee service. So as soon as our application starts, an employee service will be injected to this. So Spring Container will automatically create a new object for this employee service. And now inside the get employees, instead of returning the static string, what we can do is we can return the list of employees. So let me change the return type to list of employees, and then we are going to make use of the employee service to call the service method, which is eService.getEmployees. So let's save this. So now our application is restarted. Let's go to the Postman and let's go to the read employees request, and when I click on this send, instead of the text we do get the two JSON objects, which is the name is Bhushan and the name is Bharat. So now we have created the service class and we have hard coded the list of employees, and then we are returning it to the client. So in the upcoming videos we are going to connect it to the MySQL database, then we are going to retrieve the data from the MySQL database. Alright, so in the next video we are going to look at the other features in our Spring Boot. I will see you in the next video. Hello, welcome back to the course. Before we connecting our application to the MySQL database and performing the database operations, I would like to keep our application simple. So for that, inside the employee controller, I'm going to remove the @value annotations. I have just added these annotations just for the demonstration purpose, and also I'm going to remove this /version REST endpoint. Alright, so now we have added the URI mappings to the handler methods. Similarly, we can also add the URI mapping to the class level. So for the employee controller at the class level, we can add the URI, which is by using the @request mapping annotation, and followed by the URI. I'm going to add /API/v1. Let's import the @request mapping annotation, and now all our REST endpoints will be changed to this URL, which is localhost:8080/API/v1/ the handler methods URI mappings. Let's say employees and /employees/ID. So all our REST endpoints are prepended with the /API/v1. So let's save this, and now if I go to the Postman, and instead of modifying all these REST endpoints, what we can do is we can directly go to the environment variables and just click on this pencil icon, and we can modify the current value, which is /API/v1. So now let's go to the read employees. Let's check our application is running or not. Yes, our application is running, and let's go ahead and click on this send. We do get the 2 records, which is Bhushan and Bharat. Alright, now we have added the URI at the class level, but here is a problem. Tomorrow if I go ahead and create a one more controller, let's say customer controller or the student controller, and that controller does not contain this URI, which is /API/v1, unless if I specify this explicitly, which means if I want to prepend this /API/v1 to all the controllers, then I have to go ahead and add this URI to all the controllers. So instead of adding it to the every single controller, we can add it in one place by using the property file. So let's see how we can do that. Let me get rid of this from the controller class. Now we do not have this /API/v1 at the class level. What we can do is we can go to the application.properties file. So let's go ahead and remove these 2 properties. We don't need that, and we're going to specify the base path inside our application.properties, which is server.servlet.context path, and we will specify the base URI, which is /API/v1. So let's save this, and let's save the employee controller as well. And now if I go to the Postman, and when I click on this send, we do get the same response. Okay, so which means now if I go ahead and add a one more controller, which is a customer controller or the student controller, that controller also contains the URI, which is a /API/v1, which means if we create any REST endpoint, that is prepended with the /API/v1. Alright, so now we have seen how we can change the base URI inside the application.properties, and also we have removed the unwanted code in our application. In the next video, we are going to connect our application to the MySQL database using the data JPA. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to create the database and the database table for our application. Let's begin. I will be using MySQL database for this project. You can use any other database you want. So let's go to the MySQL workbench. And inside this, I have already created a few databases, which is MyDB and Spring Security. So I will be using this MyDB as the database for this course. You can create a new database for your project. So inside this, I have already created a few tables for other projects. So let's go ahead and create a new table for our application. So what I'll do is I'm going to first select the database, use MyDB, and then we are going to create the table, which is create table, and the table name tbl underscore employees, and we're going to create the columns, which is ID, and this is an integer of type, and this will be primary key, and this is an auto increment, and this is not null, and auto increment and primary key. And next we are going to create the other column, which is age, which is of type int, and which is also not null. And next we are going to add name, which is of type varchar, and I'm going to specify the characters 255. This is also not null. And email varchar 255, not null. And the last column is department, which is of type varchar and 255 characters, not null. Alright, we have created the table. Let's go ahead and insert some values as well. Insert into the table name, which is tbl_employee, and we're going to insert the values for name, age, email, and department, and we're going to add the values, the name, which is Bhushan, and age, I'm 28 years old, and email bhushan@gmail.com, and the department, I'm an IT guy. So let's copy this and paste it. Let's change the values to Bharat. He is 32 years old, and his email address bharat@gmail.com, and he is in the textile department. Okay, so now let's select all and click on this execute icon. This will execute the queries. And now let's go ahead and refresh this, and if you expand the tables, you can see a new table, which is tbl_employee. Okay, and if I click on this icon, it will display the list of records. Right now we have 2 records inside the table. Alright, so now we have created the database as well as the table. In the next video, we are going to add a few dependencies to our application to connect to this database, and also we are going to create an entity class to map with this table. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to add a few dependencies to our application to connect to this MySQL database, and also we are going to configure the data source in our Java application. Let's begin. So let's go to the STS, and we are going to add the 2 dependencies. One is the MySQL connector to connect to the MySQL database, and the other dependency is the data JPA. So the data JPA is nothing but the Java Persistence API, which is an specification, and the default implementation for that is the Hibernate. So the JPA will help us to connect to the MySQL database, and it is an ORM framework. So without writing SQL queries, we can use the Java objects to persist the data to the database. So that is really helpful, because in our traditional applications we used to write the SQL queries, the long SQL queries, but now using these ORM frameworks we don't need to write those SQL queries. We can use the plain Java objects to persist and read the data to the database. We will talk about the JPA and the Hibernate everything in this course, but for now let's go ahead and add the 2 dependencies to our application and configure the data source. So in order to add the dependencies, I'll just go to the Spring Initializer, and I'll quickly add the two dependencies, which is MySQL driver and the JPA dependency. So click on the explore and go ahead and take these two dependencies. Let's go back to the STS, open the pom.xml, let's add these two dependencies and format this, Ctrl+Shift+F, and let's save this. So this will download all the dependencies that are related to JPA and MySQL connector. Okay, so now let's go to the application.properties. We need to configure the data source. So let's add the properties, which is spring.datasource.url and the MySQL driver URL, which is jdbc:/localhost:3306, which is the default port, / the database name. In my case, it's MyDB. Make sure to change the database name according to your database name. Next, we are going to specify the database username and password. spring.datasource.user.name, or I think it's username, and the username it's scbhushan05. Next, we are going to specify the password, spring.datasource.password, scbhushan05. Make sure to change the username and password as per your MySQL database installation. With all this, let's save this. So now our application will restart, and now we have connected to the MySQL database. Okay, in the next video, we are going to create an entity class and we are going to map the Java object to the database table. That is coming up in the next video. I will see you in the next video. Hello, welcome back to the course. In this video, we are going to create an entity class and we are going to map that entity class with the database table. Let's begin. So if you remember, in our previous videos, we have created an employee class. So let me open that class. And we have created this employee class a few lectures back. We can use this class as an entity class. So in order to make this class an entity class, all we need to do is we need to add the JPA annotation. So entity class is a special type of class that represents the database table inside our application. So in order to make this class an entity class, all we need to do is annotate this with the @entity annotation. So let's import this. Okay, we are not able to see the @entity annotation. Let's actually go to the pom.xml. Let's verify whether we have added the JPA dependency or not. Web test, starter, dev tools, Lombok, Java. Okay, we have added the JPA dependency, but for some reasons we are not able to see that dependency inside this. Let's go back to the browser, and okay, I have not copied the JPA dependency. Okay, so the JPA dependency, let's copy this. Let's go back to the pom.xml and add it. So let's format this and let's save this. So once it downloads the JPA dependencies, we can go ahead and import that. Let's import the @entity annotation. Still we are not able to see. Let's remove this and let's add the @entity annotation. Yes, now we can see. Okay, so now we have added the @entity annotation. So by adding this annotation, this class represents the database table inside our application. Okay, so but we also need to add a few other dependencies to make this class mapped with the database table. So first we need to specify the table name. So because inside our database we have a different table name, we have to map that as well. So for that we can directly use the table name within the entity itself, like tbl underscore employee, or we can use a one more annotation, which is the table annotation. Okay, this will provide the table information. In our case we are using the table name, which is tbl underscore employee. Let's import this add table annotation as well, which is from the javax.persistence package. So now we have added the two annotations, which is add entity annotation that will represent this class as the database table, and add table annotation provides the table information. And now we need to map these fields with the database table columns. So for that we are going to use one more annotation, which is add column annotation, and we can specify the column names. Name is equal to, in our database we have ID, age, name, email and department. We can map those columns with the field names. In this case it's name. Let's copy this and paste it. Age, which is for the age field, and location, which is for the location field, and email, which is for the email field, and department for the department field. So let's import the add column annotation. Okay, we are almost done, but we have to add one more information, which is the ID information. So if you remember, when we are creating the database table, we have provided the ID as the primary key. Similarly, inside our entity class we also need to tell our JPA which is the primary key field. So in this case it's ID. Unfortunately we forgot to create that field, so let's create the private long ID. This is mapped to the ID column, and we also make this field as the primary key column. So for that we are going to use add ID annotation. Let's import that ID as well. So we have to add one more piece of information, which is the generated value. If you remember, in our database we have added the auto increment, which means every time when we add a new record, the database will automatically increment the ID. Okay, similarly we have to tell our JPA to increment the ID field by 1. So for that we are going to use add generated value. This will take the strategy generated value, or sorry, the generated type, which is auto, which is nothing but we are telling the JPA that you know the database which we are using. Similarly you can use the strategy to increment the values. Okay, we also have other options like you can see the other options here, which is identity, sequence, table and other things. Sequence, which is completely for the Oracle database and other stuffs. The identity, which is nothing but incrementing by 1, and the table, which is for other purpose. We don't need to discuss about that now. So instead of specifying this identity, sequence, table, we are just telling to use the auto, because auto, the JPA itself will use the underlying database and it will automatically increment the values for us. So that's the purpose of using the auto. So now we are done with configuring the entity class. So now this entity class, the employee class, completely mapped with the database table which we have created. Okay, so now in the next video we are going to create a repository and we are going to perform the very first database operations, which is read operation. I will see you in the next video. Hello, welcome back to the course. In this video we are going to create the repository, the JPA repository, and we are going to perform the database operation. Let's begin. So let's go to the project structure, and inside the source main Java I'm going to create a new package, which is the repository, just like how we have created the service package and the controller package. Okay, so now we have created a new package, which is the repository package. Inside this I'm going to create a new interface. This is the employee repository, and this is going to extend the interface, which is the JPA repository. So JPA repository. So we also have one more repository, which is the CRUD repository. You can use that repository as well. Click finish. Okay, so the JPA repository will provide the database methods like create, read, update and delete. You can use those methods to perform the database operations. We're going to look at those methods in just a bit. So before that we have to specify the entity name. We have to tell what is the entity name that we are going to perform the database operation. So in our case the entity class is employee, and we need to specify the data type of the primary key. So in this case it's long. So if you look at the employee class, and we have marked this ID field as the primary key field, and the data type of this field is long, and we need to provide that data type of the field, which is long. Let's import the employee, and we need to mark this interface as the @repository annotation. Okay, now we have created the repository. All we need to do is we have to auto wire this repository inside our service class. Let's open the service class, and first of all I'm going to get rid of these hard-coded values. We don't need that now because we are going to fetch the values from the database. First we need to auto wire the repository. So employee repository, let's add the auto wire annotation. Inside this get employees method we are going to make use of this employee repository. So repository, and if you just put a dot you will see all the methods available inside the employee repository. So if you scroll down you will see a method which is save, and this is going to take the employee object. So let's use this. And okay, I'm sorry, we are not going to perform the create operation. Instead we are going to fetching the database records. So for that we need to use the other method, which is, let's actually find that method, and you can see find all. This will return the list of employee. So let's use this method, and this is going to return the list of employees. So let's return this. So let's save this. So now we have called the method return. We have created the method get employees, and inside this we are going to return the repository method, which is find all. So let's actually save the repository as well. Okay, so now all we need to do is inside our controller we are calling the service method. The service layer will call the repository method, which is find all. All we need to do is we need to test our work. So let's go to the Postman, and all we need to do is just click on this send button. We should get the response, but for some reason we are not getting the response. Let's actually go to the console and see what do we get. We are getting some exception. Let me expand this so that we can see the error. JPA repository class not found exception. Employee controller unsatisfied. Okay, let's actually stop this and restart the application and we'll see. I'm going to restart the application. Alright, the application is started without any errors. Let's go to the Postman and click on this send. We should get the 2 records, but unfortunately we are getting some error, which is could not extract the results at SQL nested exception. This is so weird. Okay, unknown column, fine. Let's go ahead and see what is there inside our employee class. So inside this we have this location, but in our database we do not have the location. Let's go ahead and add the location. Fine, location and varchar and 255 not null. Okay, let's actually add the location as well. India and Australia. Okay, so now I will just go ahead and drop this table. Now let's select this and click on this. First of all, let me clear the console. I can also see the logs or the console messages. Just click on this execute icon. It should execute, but again there is some problem because we haven't specified the location. I'm doing a lot of mistakes. That's completely fine. It will happen. Okay, so let's actually go ahead and insert these 2 records. Okay, the 2 records has been inserted to the database. Let's refresh this and we should see the 2 records inside the database: ID, age, name, email, department and location. So now inside our entity class we have mapped the location column as well. Okay, so this time it should work. Let's go ahead and test our work. Let's click on this send. We should get the 2 records, which is Bhushan and Bharat. Alright, finally we have fetched the records from the database, and I have did some mistakes in the while developing. That's completely fine. The first mistake that I have done is I forgot to add the location column inside the database, so I have added that. So I have added the location, and also while inserting I forgot to add the location as well. Again I have modified that and I have added the location as well, and I have rerun the queries again, and now we are in the clean slate, and again I have tested the application. It works fine. Alright, so now we have created the very first REST endpoint that is connecting to the database, and it is fetching the records from the database. In the next video we are going to perform the other database operations like creating the record and fetching the single record based on the ID, and also we are going to perform the delete operation and other database operations. I will see you in the next video. Hi, welcome back to the course. In this video we are going to save the records to the database. Let's begin. So we need to create a service method in order to save the records to the database. So let's do that. So before that, in case if you haven't subscribed to my YouTube channel, then subscribe to my channel and click on the bell icon to get notified whenever I upload a new video. Also check out my website bhushansirgur.in, wherein I write every day a new article on different topics, make sure to check out that. I have started writing the blog post on Spring security. Check out that as well. So now back to the video. So let's open the employee service. So inside this interface, I'm going to declare a new method. This is going to return the employee object itself, and I'm going to call this save employee. So this will take the employee object as an argument. Let's save this. So now inside our service implementation class, we need to implement that method. So all I need is to call the repository method using the employee repository. eRepository dot, there is a method called save, and for this save method we are going to pass the employee object. And if you look at this return type, this is going to return the employee object. So let's return the employee object. Now let's save this. Now let's go to the employee controller. We need to call the service method. So inside the post mapping, I will just get rid of this return string, and I'm going to change the return type to employee. And inside this, we're going to call the service method using the employee service, save employee, and we're going to pass the employee object. Alright, so now let's save this and let's run our application. Alright, our application is started. Let's switch to the Postman, and I'm going to open the create employee request. And if you look at this, we have this app details request. I'm going to delete this because we have removed that REST endpoint in our controller. So I'm going to delete this request, delete this. Alright, inside the post request, inside the body, we have this JSON data. I'm going to click on this send, and we should expect the response, but we are getting the error. This is expected. I intentionally created this error. So let's actually switch to the STS and see the error. Let me expand this, and if you look at this, we are getting the error that is mydb.hibernate_sequence doesn't exist, which means let me open the employee entity class. So let me open the, so the error is causing because of this generation type.auto. We need to change this to identity. Okay, so earlier I told that if you use auto, then JPA itself will take the underlying database and it will automatically generate the ID for us. But if you look at the Maven dependencies, let me expand this, and if you look at the Maven dependencies, we are using the Hibernate version. The Hibernate version which we are using is 5.4.31. So if the Hibernate version is below 5, which is 3.x or 4.x, then generation type.auto will work. From Hibernate 5, there are some complications. I don't go over into that complications. The generation type.auto will not work for the MySQL database. You need to change it to generation type.identity. So now let's save this, and our application will restart. Our application is restart. Let's switch to the Postman, and now when I click on this send, we should get the response, which is the employee response, and you can look at the ID. The employee ID is 6, which automatically generates the database for us. So remember that generation type.auto will only work if you are using the Hibernate 4 or the 3. If you're using a Hibernate 5, then you need to change it to generation type.identity. Alright, so now we have completed the post mapping. We have saving the records to the database. Let's actually one more record we will insert so that we will get confirmed. So let me change this to test 3, and let's go ahead and click on this send, and you can see now we have a different ID which is 7 and the name is test 3. So let's actually verify in the database as well. Let's go to the database, and inside our TBL employee I'm going to click on this execute query, and you can see now we have added the two records just now, test and test3. Alright, so now we have completed the post mapping. In the next video we are going to look at the other operations. I will see you in the next video. Hi, welcome back to the course. In this video we are going to fetch a single employee record by using a GET request. Let's begin. So let me close this employee class, and also I'm going to minimize this Maven dependencies. And now inside the employee service I'm going to create a new method. I'm going to declare a new method. This is going to return an employee object, and I'm going to call this get single employee, and we're going to pass the employee ID, which is of type long, and the employee ID. And inside the service implementation class we are going to implement that method. So we're going to make use of the employee repository to call the repository method. Employee repository, we have a method called find by ID, and this is going to take the employee ID as an argument. We're going to pass the employee ID. So this is going to return an optional of employee. So because we may get an employee object, we may not get an employee object. So for that, this is going to return an optional of employee object. So let me import the optional from the util package. So we are going to write a condition. If the employee is present, we are going to return the employee object. So return employee dot get. If the employee is not present, then we are going to throw an exception, throw new runtime exception. I'm not going to get into the exceptions as of now, so I'm just going to throw the runtime exception, and we're going to pass a string which is employee is not found for the ID. We're going to concatenate the ID, the one we are looking for. Alright, now let's save this, and inside our employee controller we are going to call the service method. So we have this get mapping, and this I'm going to remove this string, and I'm going to change the return type to employee. So we're going to make use of the employee service to call the service method, which is get a single employee, and we're going to pass the ID. So now let's save this. Our application will restart. Let's switch to the Postman. First of all, I'll go to the read employees and I'll click send. We have few records, the ID 1, 2, 3, 4, 5, 6, 7. So let's actually try to fetch the employee which is having the ID 6, which is the employee name is test. So let me go to the read employee, and I'll change the employee ID to 6, and when I click on this send, we should get a single employee which is having the ID 6. So now let's try for employee ID 64, which is not even present in our database. Let's click on this send. We should get an exception, that is runtime exception, employee is not found for the ID 64. Alright, so now we have completed the get mapping. We are fetching the employee record from the database, and in the next couple of videos we are going to complete the updating the employee record and the deleting the employee records. I will see you in the next video. Hi, welcome back to the course. In this video we are going to delete the employee records from the database. Let's begin. So inside our employee service I'm going to declare a new method. This is going to return void, and we're going to call this method as delete employee, and we are going to pass the employee ID as an argument. Let's save this. Inside our service implementation class, we are going to implement that method. So let's get rid of this comment. We're going to make use of the employee repository to call the repository method. So we have two different methods. One is delete and find by delete. Okay, we have a method called delete and delete by ID. So we can use delete if we have an employee object, or we can use delete by ID if we have a employee ID. So since we are having the employee ID, so let's actually call the delete by ID, and we're going to pass the employee ID. And let me save this, and inside our employee controller, we are going to make use of the employee service to call the service method. So employee service dot delete employee, and we're going to pass the ID to it. Let me get rid of this return type. I will change this to void, or even we can change this to HTTP status, but we're not going to talk about the HTTP status codes and the other properties, other concepts. We're going to talk about that later, but for now let's keep it simple. This is going to return void. Alright, so now let's save this, and what we can do is let's go to the Postman. First, let's go to the read employees. Let's click on this send. We have a few records. Let's actually try to delete the 5th record, which is having the name test, age 28, and local location is South Africa. Let's go to the delete employee, and the ID, I'm going to change this to 5. And when I click on this send, we do get the 200 status code, which is good. And now let's actually go to the read employees and click on this send. We should not see the ID 5. You can see now we have 4 and 6 and 7. The 5 is not in the response, so which means it is deleted from the database, and our delete employee is working as expected. Alright, in this video we have deleted the employee records from the database. In the next video, we are going to discuss about the last database operation, which is updating the record. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to update the employee details in the database. Let's begin. So what I'll do is I'm going to declare a new method inside the employee service. So this is going to return the employee object itself. Update employee. This will take the employee ID as an argument, as well as the employee object. So employee and employee. In fact, the service method does not take an employee ID. We don't need this. This will take only the employee object. So let's save this. Inside our service implementation, we are going to implement this method. So we're going to make use of the repository method, employee repository. We're going to call the same method which we have used for saving the records, which is save, and this is going to take the employee object as an argument. So the difference between this and this, so this employee object does not contain the ID, but this employee object will contain the ID. So depending upon the ID, the save method will perform the update and save operation. So if the employee object does not contain the ID, then it is going to create a new record inside the database. But if the object contains the ID, then the save method will treat that as an existing object and it will update the object. So we're going to make use of the same method, which is the save method for both save and update operation. So remember that. So let me save this. Now inside our employee controller, we are going to call the method, service method. So return employee service dot update employee, and we're going to pass the employee object. But before that, we are going to attach the ID to it, employee dot set ID, and we're going to pass the ID to that object. So now this employee object does contain the employee ID. So our repository save method will update the object instead of creating a new record. Let's test our work. So I have saved the employee controller. Let's switch to the Postman. We are going to update the second record, which is Bharat. I'm going to change the Bharat age to 30, and location I'll change this to India, and email I'll change this to bharatit@gmail.com. So let me copy this content. Now let's go to the update employee. Let's actually get rid of this and paste this. We don't need to pass the ID because inside our controller it is going to add. Let's pass the employees /2, and let me change this to the age. I'll change this to 30, and location I'll change this to India. I'll change the email ID bharat.it, and department textile. So now when I click on this send, we should get the response, the employee response, that is ID2, name Bharat, age 30, location India, bharatit@gmail.com, department textile. Let's actually go to the read employees and click on this send. Inside this also our object should be updated. You can see ID2 Bharat 30 India, bharat.it@gmail.com. We should not generated the new record. Yes, it is not generated it as a new record. Instead it updates the existing object. We can also verify that in our database. Let's go ahead and execute this query, and we can see the ID2, the age 30, bharat.it@gmail.com, and location India. Alright, so now we have completed all the database operations, which is create, read, update, and delete, and this completes our CRUD operations section. In the next video, we're going to start implementing the pagination and sorting for this application. So I will see you in the next video. Hello, welcome back to the course. In the previous couple of videos, we have discussed to map the Java entity objects with the database tables. We have run the SQL queries manually, and we have mapped the Java objects with the database tables. But there is also one more way. We don't need to create the SQL queries, or we don't need to create the tables manually. The Hibernate or the JPA itself will create the tables for us depending upon the entity annotations. So in this video, let's see how the JPA will create the database tables for us. So what I need to do is, first I'll just go to the MySQL database, and I'm going to drop the table. So we have this employee table, just right click and drop this table. So now inside our database MyDB, we do not have the tbl_employees table. So now let's go to our STS tool. Let's open the application.properties file. We are going to add one more JPA property, which is spring.jpa.hibernate.ddl-auto. I think my STS becomes very slow. Okay, so you can see ddl-auto, and it has a few values, and if I scroll down, you can see we can provide the values like create, drop, and few other properties are there. Okay, so what we can do is we can put a equals, then you can press control space. You can see we have a values like create, -drop, none, update, and validate. Okay, so we are not going to discuss all these values. We are just stick to the update. So what the update will do, when we run our application, and depending upon the entity annotations, the JPA will create the database tables for us. And in the future, if we made any modifications in our entity class, let's say if we had any more columns, it will automatically, next time when the application runs, it will automatically add the extra column for us. So that is what the update. So if you talk about the create, what the create will do is, each time when we run our application, each time it will drop the tables and it will recreate the tables. So which means all our database entries, the values, it will be deleted. So it's always good to use the update. So now let's save this, and now our application will restart. I think we have not started our application. Let's go ahead and start our application. I'm going to start the application. Right now in our database we do not have the table, which is tbl_employees, but with this one single property, now in our database we are able to see the database table. So let's go to the MySQL database and let's go ahead and refresh this, and you can see now we have a new table, which is tbl_employee. So we haven't created this table, but the JPA will create the table for us based on the entity annotations. So let's go ahead and test our work. Let's go to the Postman, and let me open the Postman, and let's go to the create employee. And right now we have this JSON payload. Let's go ahead and click on this send. We should get the response, which is the ID 1, name test3, age 28, and some other options. Okay, so now let's go to the read employees, and when I click on this send, we should get a single record which we have added just now. We can also go ahead and add up one more property. Let's go to the create employee. Let's change this to test4. Let me change this to test4 and click send. We should get another record, another response, which is of ID 2. Now if I go to the read employees, click on this send, we should get the 2 records. We can also delete that employee. Click on this delete. Let's change this to 1 and click send. We should get the status 200. Now if I go to the read employees, we should get a single record. Alright, this is another feature that is provided by JPA. We are going to use this option only in the development purpose. We are not going to use this in the production. In the production, we are going to take the scripts and we will run the we will create the tables manually. Okay, so for the development purpose, this is a very good feature that is provided by JPA. Alright, that's all about this video. In the next video, we are going to talk about some other features. I will see you in the next video. Hello, welcome back to the course. In this video, we are going to see how to create the timestamps in the database. So in real-time production applications, it is very common to generate the timestamps for every database table, just to keep track of the records or to keep track of the logging purposes, and we are going to add the timestamps. So in this video, let's see how to add the timestamps, and the JPA has provided a few annotations to keep track of the timestamps. So let's go to the employee class, and inside this we are going to create a 2 fields. We're going to add the 2 fields, which is private, and this will be date, and I'm going to name it as created at and private date update at. Let's import the date from the util package, and we're going to map the column. So let's copy this and map this. I'll change this column name to created underscore at, and similarly I'll change this to updated underscore at, and we are going to add the annotations which is provided by the JPA, which is at creation timestamp. Creation timestamp. Let's import this, and we are going to provide the few properties, which is nullable. I think this is only creation timestamp, and we need to provide the options to the column annotation. Yes, it's nullable, and I'll set this to false, and updatable, I'll set this to false. Similarly, for the update at, we are going to use the annotation which is update timestamp, Let's import this. Alright, so now we have added the annotation at creation timestamp for the created at and at update timestamp for the update at field or the column. So now what will happen whenever we insert a new record? So the created at and updated date will be same, okay? But whenever we are updating the record, at the time the updated date will be updated to the current time. Okay, so let's actually see this in action. Let me save this and our application will restart, and you can see that in the database the columns will be generated. So let's actually refresh this and let's actually see the tables structure, and you can see extra column has been added which is updated at, but the created at table has not been created. Let's go ahead and see that. Okay, that is because we need to drop the table because we have added the nullable false and updatable false. Because of that reason, let's go ahead and drop this table. Drop the table. Now actually give some white space and let's save this. Application will restart. Okay, and now if you take a look at the database, let me execute this. And you can see now we have a created at and updated at. Okay, so let's go ahead and insert the record. I'll go to the Postman and let's go to the create employee. We have this JSON payload, and if you look at this, we are not passing the created at and updated at. So let's go ahead and click on this send, and we should get the response, and you can see now we have the created at and updated at as the response. And if you look at the created at and updated at, time and date both are same. And now let's go ahead and insert one more record. I will change this to test 5 and click send. We should get the one more record. And now let's go to the read employees, click send. We should get the 2 records, the ID1 and ID2. And now let's go ahead and try to update one of the record. I'm going to update the first record. So let's take a copy of this. Let's copy this, and now let's go to the update employee and inside this JSON payload, let me get rid of this ID and let's pass the ID 1, and we need to change this to test demo, and age I will change this to 30 instead of South Africa. I'll set this to India. Okay, now you can see the created at and updated at time both are same, but when we click on this send, once we get the response, you can see that the updated at time will be differ from the created at. Okay, only updated at field is updated with the current time. Okay, this is a very useful feature when you are working with the production grade applications. In case if you want to keep track of the records, or in case if you want to monitor the timestamps, or if you want to add the timestamps to your database for every table, then you can use these annotations, the at creation timestamp and at update timestamp annotations. It will automatically, JPA will automatically takes care of the timestamps. Alright, that's all about this video. In the next video, we are going to discuss about some more features provided by the JPA. I will see you in the next video. Hello, welcome back to the course. In this video, we are going to discuss about the at column annotation. So if you look at our entity class, inside this entity class, we have added so many annotations. Okay, ID, generated value, at column, at toString, at getter, at setter, and so many annotations we have added. But all these annotations are not mandatory annotations. Okay, so in fact, this at column annotation is not mandatory annotation. Anytime if you want to map the field name with the database column name, at the time we will use at column annotation. But there is a catch. If you want to create our column name which is same as the field name, then we don't need to add this at column annotation. Okay, basically if the field name and the column name, if it is both are same, then we don't need to add the at column annotation. We can get rid of that. So in this case, I'm going to get rid of this ID as well as the name, as well as the age, location, email, department. I'm going to keep only for the created at and updated at. because I want the column name to be different from the field name. So with this changes, now when I save this, application will restart and our application still works as expected. Let's go ahead and test our work. Let me open the Postman and let's go to the get employees or the read employees, and let's click on this send. Still we do get the 2 records, and let's go to the create employee and let's change this to test 8, and when I click on this send, still we do get the response which is test 8, and let's go to the read employees, click send. We should get the 3 records. Okay, so remember that @column annotation is not a mandatory annotation. Anytime if the column name and the field name both are same, then we don't need to add the @column annotation. We can skip that. Alright, that's all about this video. In the next video, we are going to see how to validate the entity class. So I will see you in the next video. Hi, welcome back to the course. In this video, we are going to add a validation to our application. So let's begin. So let me open the Postman. So inside the Postman, I have opened the create employee request, and inside this body, we are sending the JSON payload. Okay, we are passing the name, age, location, email, and department. So for some reasons, even if I don't pass anything, even if I pass an empty body, let's click on the send, still our application works and still we do get the response. So we do get the name, age, location, email, department as null, but still our application works without any errors. But this is the behavior that we don't want. Okay, so we have to set up some validations saying that user, the name is mandatory and the location is mandatory, the email you should pass the valid email address, and the department you should not pass null. Okay, such kind of validations we need to set up. Okay, so in order to do that, we are going to add a dependency which is the Hibernate Validator. So let's go ahead and add the dependency first. So let's go to the browser and navigate to the Spring Initializer, and let's click on this add dependencies and search for validation. So you can see bean validation with a Hibernate Validator. This is the one we are going to use. Click on this and click explore, and if you scroll down, you can see the dependency, the starter validation dependency. So just copy this dependency and switch to the STS and navigate to the pom.xml. So inside this pom.xml, at the very end, we are going to add the dependency. So we can format it, Ctrl+Shift+F, and let's save this. So this is going to download all the dependencies that are required for the Hibernate Validator, and our application will restart. Okay, so now we need to set up the validation. So in order to do that, we are going to open up the entity class which is the employee.java. So inside this we have defined the fields, and we have to tell the Hibernate that these are the fields that are mandatory, and the way to do is by adding the annotations. So let's say the name should not be null, so we are going to add the validation which is @not null. So let's import this. We are going to import from the javax.validation.constraints.notNull package, and similarly let's copy this. I want the email, not the email, the department should not be null. I'm going to add that as well. For the age, what I'll do is I'm going to set the default value which is 0. If the user does not provide an age, then we are going to set the default value as 0. Since this is a long, I'm going to add L. Okay, so now we have added the @not null annotation to the name property and as well as the department property. So we have set up the validations, but we have to validate whenever the user try to send the null values, right? So we're going to do that inside our employee controller. So inside our employee controller, when the user make a post request, the JSON data will be bind to the employee object. Okay, so before binding it, we are going to validate that. If the user is sending the null values for the name and department, then we are going to throw an exception. So we are going to add the @valid annotation just before the @request body annotation. So let's import this, and now let's save this So whenever the user sends a null values to the name and department before it bind it to the JSON data binding to the employee object, it is going to throw an exception. So let's test our work. It should work. Let's go to the Postman, and I'm not sending any values inside our JSON payload. When I click on this send, we should get the exception, but it is still giving the response. Sometimes this will happen. You can just stop the server and restart the application again. So let's restart. Okay, our application is restarted. Now let's switch to the Postman, and now when I click on this send, we should get the error or the exception. You can see the status is 400. The error is a bad request. It will display a big long exception, but we are not going to looking into this completely. Just scroll down. We are looking for one of the default message, the property, and you can see the default message that is must not be null. Okay, you can see the field name. Okay, the name field must not be null. Okay, this is the error that we're getting. In fact, we can change this default message. Let's go to the employee class, and we can provide our custom message. So this will take the message as an options. Okay, here we are going to pass our custom message. Name should not be null. Similarly, we are going to add this to the department as well. Department should not be null. So let's save this. Let's switch to the Postman, and when I click on this send, we should get the default message, name should not be null. So let's actually provide the name. This will be test validation. Now when I click on this send, we do get one more exception because the department we are also passing it as null. Now if I look at the default message, department should not be null. Okay, so let's provide the department. This will be the textile department. And now when I click on this send, we do get the response, but if you look at the age, we do get the age as 0 because we are not passing the value for the age, and it is taking the default value, which is 0. Alright, so we can also add other properties. You can explore more on the Hibernate Validator, but I'm going to add one more validator, which is the @email annotation. Okay, saying that the user should pass the valid email address. Okay, so for that we are going to add the @email annotation. You can see javax.validation.constraints package. So let's save this. We can also provide the custom message. As I said before, message, please enter the valid email address. So let's save this. Our application restarts. Let's switch to the Postman, and this time what I'll do is I'm going to provide the email address, but let's say this is Bhushan. Okay, this is not an valid email address, right? The valid email address should contain @ and .com. There are some formats there. Okay, so now let's go ahead and click on this send. It should throw an exception. If I scroll down, look at the default message, please enter the valid email address. Let's add the @gmail.com. This time it should work. Click on this send. We do get the response. You can see bhushan@gmail.com. Alright, this way we can set up the validation. Again, you can explore more about the Hibernate Validator. There are plenty of annotations are available to validate the model class or the bean class. Alright, that's all about this video. In the next video, we are going to customize our error messages. Instead of throwing a long exception, we are going to customize it, and we are going to only display the default message inside our response. So that is coming up in the next video. I will see you in the next video. Hi, welcome back to the course. In the previous video, we have set up the validation to our application, and in this video, we're going to continue with that. In this video, we are going to, instead of displaying the complete error message, we are going to customize that error message and we're going to display only the default messages. Let's see how we can do that. So let's go to the employee controller, and before that I'm going to close this pom.xml. We don't need that. Okay, so inside this @post mapping annotation, when we are binding the JSON data to the model class or the entity class, we are going to validate whether user is passing the null values or not. If the user is passing null values, then we are going to throw the exception. Okay, so this is going to throw an exception called method argument not valid exception. Okay, so we are going to create a global exception handler for application, and we are going to handle that exception. Okay, so let's see how we can do that. So let's open the project structure, and inside this inside the source main Java, I'm going to create a new package. And the package name, which is exception. And inside this, I'm going to create a global exception class. I'm going to call this global exception handler. And this is going to extend a class which is response entity exception handler. Response, I think this is interface. Okay, we are looking inside the interfaces. We should click on this browse, and now we should find for response entity exception handler and click finish. So now we have created a global exception class, and it is extended the response entity exception handler. In order to make this class exception handler, which means in order to make this as a global exception handler class, we need to add an annotation called @controller_advice. So we're going to add the @controller_advice. So let's import this. So with this one annotation, this class is able to handle all the exceptions globally. Okay, so inside this, we are going to override one of the method, which is handle method argument not valid. Handle method, just press Ctrl space. Okay, we are going to override the method which is handle method argument not valid. So inside this, let me get rid of these comments and everything. So this is going to take the argument which is method argument not valid exception, and headers, status, and the web request. So inside this, I'm going to create a map. Okay, so this will be of type string and object. The key will be string and value will be object. This I'm going to call this body, and I'm going to use linked hash map. So let's import this. So now we are going to add a few keys. So first one is timestamp, and I'm going to take the current milliseconds from the system. So system.current milliseconds, and body.put. We're going to add the status, and we do get the status from the status. We have this HTTP status, so let's make use of this status dot value. And next, we are going to get all the errors. Okay, so we may get a multiple errors because inside our application we may set up multiple fields for the validation. So for that, I'm going to create a list of string. So list of strings, I'm going to call this errors, and we do get errors from the method argument not valid exception. So this will be, you can see, exception dot get binding result, and on this binding result I'm going to call the get field errors, and we're going to, it's not error, we do have two different methods. One is get field error and field errors. We'll make use of the get field errors, and on this we are going to call the stream, and on this stream we are going to call the map method. So we're going to get the default message, get default message. On this map method we are going to call the collect method to collect all the errors. So collectors dot collectors dot toList, and finally let me import the list as well from the util package, and finally we are going to put the errors, and we're going to pass the errors which we have stored inside our list, and finally we are going to return the response entity, because this is the return type of response entity of object type. So return new response entity, and we are going to pass the body as well as the status, and you can provide the object type. Okay, so let's save this. Okay, so don't worry about this class. Okay, we have created a global exception class, and we have annotated with the add controller advice, and we have overridden the method handler. Let me expand this. Okay, we have override the method handle method argument not valid exception. This method will be triggered whenever we are binding the JSON value to the model object. If there is any exception throws, that time this method is going to execute. Okay, so inside this we have created the map, which is a linked hash map, and we are going to add a few properties, which is a timestamp, status, errors, and for the errors we are going to get the values from the binding result, and we will get the field errors, and this will return an array. On that we are going to call the stream object, and on the stream we are going to make use of the map to collect all the values, and finally we are going to pass that errors to the body, and finally we will return the body and the status back to the client. So now let's save this. That's it, we don't have to do anything. It will automatically displays the default error messages inside our client. So let's go to the Postman, and now let me get rid of this, and when I click on this send, we should get the error messages. You can see timestamp, status, and errors. Inside the errors we do have a messages like name should not be null, department should not be null. Okay, so this is how we can customize the HTTP response. We have just created a global exception class, and we have annotated with the add controller advice, and we have created a map, and inside the map we have stored all our errors, and we have displayed to the client. That's all about this video. Thank you so much for watching. I will see you in the next video. Hi, welcome back to the course. In the previous couple of videos we have discussed a lot about the Hibernate validators. So before we move on to the other concepts, I would like to discuss few more annotations that are provided by the Hibernate validator. So let's begin. So let me open the Postman, and we have already discussed, if I try to send the request for the create employee without entering any values inside the body, we do get the error messages, as you can see. So let's go ahead and click on this send. We do get the error messages, the department should not be null and name should not be null. Okay, so let's actually try to send the empty values, and let's see what will happen. So instead of sending the null values, I'm going to send the empty values, and similarly for the department I will pass the empty values, and for the email I will pass an valid email address, bhushan@gmail.com. So with this, if I go ahead and send the request, we should get the error messages similar like this. Let's see what will happen. When I click on this send, we didn't get any error messages. Instead we get the HTTP response, and the record has been saved in the database. which means the annotation which we have added inside our employee class, it fails. The @not null annotation did not check for the empty values. Okay, so it will only check for the null values. So then what is the alternate solution? So for this reason, the Hibernate provided one more annotation, which is @empty annotation. So we can use @not empty. We can import this. So let me copy this and I will paste it for the department as well. So with this, let me save my application, save the file, and now let's switch to the Postman. And this time, if I pass an empty values, we should get the error messages instead of creating the new record. Let's go ahead and try that. When I click on this send, we should get the error messages, that is name should not be null. And okay, I have copied and pasted it. I didn't change it to department. That is why it is showing the same message, error message, department should not be null. Let's save this. Our application restarts, and when I go ahead and click on this send, we should get the two different validation messages, that is name should not be null and department should not be null. Okay, so with this we have understand @not annotation is only checks for the null, and @not empty annotation will checks for both null as well as the empty values. But what will happen if I pass an space within the, instead of passing the value, if I pass an empty space, what will happen? Let's actually see that. So with this, now if I go ahead and send the request, what will happen? Again, it didn't validate the bean, instead it creates a new object. We do get the HTTP response back, which means @not empty annotation will also not work for our requirement. Okay, so for this reason, the Hibernate provided one more annotation, which is @not blank annotation. So we can use @not blank annotation, @not blank annotation. Let's import this from the constraint.notBlank package. So let's copy this and paste it for the department as well. So with this, let's save this. Our application restarts. Let's switch to the Postman, and if I go ahead and click on this send, we should get the validation messages, that is department should not be null and name should not be null. So with this, what we have understand is @blank annotation will also check for the empty values, the null values, as well as the characters. Okay, if the character is not available, then it will throw the validation messages. Okay, basically it will trim the value and it will checks for the null as well as the empty values. Okay, so remember that anytime if you want to validate, the go-to approach is for @blank annotation. Okay, so in case if you want to understand more about the @not null, @blank and @empty annotation, you can check out this Stack Overflow answer. I drop a link in the description section of this video for this post, and they have given a complete detailed overview of the @not null, @empty, @blank annotation with the examples. Okay, you can check out these examples to understand more about the annotations. Alright, this is all about the Hibernate validators. So now we have wrapped up the validation part. In the next part, we are going to discuss about the pagination and sorting. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to discuss about the HTTP status codes. So let's begin. So far in our application, we have created 5 HTTP requests, and all these requests perform the specific database operation. When we make a HTTP request, the request may get successful, may not be successful. But how does the client application knows that whether the request has been successful or the request has been failed? So we can tell the client application whether the request has been successful or not with the help of the status codes. There are plenty of HTTP status codes. We are not going to discuss about all the HTTP status codes. We are going to discuss about the 3 or 4 HTTP status codes which are required for our application. So for create request or for the create resource, we are going to send a specific HTTP status code. Similarly, for the delete request, we are going to display the specific HTTP response code, and for the update and for the save or from the getting the list of records, we are going to display a specific HTTP status code. We will discuss all those one by one. So before that, as of now, for all these HTTP requests, we are getting the 200 as the status HTTP status code. So you can see that. So I'm going to send a request again. You can see now we have created a new resource. We are getting the 200 as the status code. If I go to the read employees and if I click on this send, again we will get the 200 as the status code. Similarly, for even the delete also, we will be getting the same HTTP response 21. If I go and delete the 21, you can see we get the 200 as the status code. Okay, this is not the behavior we want. We have to tell the client that whenever we delete the request, we are going to display a specific HTTP response. Okay, so in order to do that, we are going to modify our controller. Let's go to the STS, and inside the controller, right now we are just returning the data. Instead of returning the data, we are going to return the response entity. We have already discussed about the response entity. If I go here, the global exception handler, the handle method argument not valid method is actually returning the response entity. The response entity not only return the data, it will also contains the other informations like the HTTP status code or the headers and some more information. So we can pass all those information back to the client, and that's exactly what we are going to do in our employee controller. So inside the employee controller, we are going to change this to response entity. So let's change this to response entity, response entity, and this will be of type list of employees. Let's import the response entity, and we need to change this to new response entity. So new response entity, and which is of type list of employee, and we need to wrap this inside the brackets, and the first parameter will take the data and the second parameter will take the HTTP status. So HTTP status dot, in this case we are going to send the HTTP 200, which is okay, because we are reading the information from the database. So once we get the list of records, we are going to send the HTTP status as okay or the 200. Similarly, for the post mapping, we are going to send the created as the HTTP status. So let's actually change this to response entity of type employee, and I will change this to new response entity. Let's wrap this within the brackets, and the second parameter will be HTTP status dot, you can see we have a created, which is nothing but 201, which is created, which means we are creating a new resource. Okay, so with the help of this status code, the client will understand the resource has been created and it will display a valid or the proper message to the user. Similarly, for the delete, we are going to send the response entity, response we are going to send the HTTP status, and here we are going to return new response entity, we just pass the HTTP status. The HTTP status for the delete is no content. Okay, so which is the no content. If you look at the no content, you can see 204 no content. So if the client sees the HTTP status code for 201, it will understand that the record has been deleted from the database and it will display a proper message to the user. So we will use no content for the delete resource. Let's actually import the response entity. Alright, so let's save this, and we need to display the response entity, or we need to display the HTTP status code for this get mappings. It is going to retrieve the single employee. So for that we are going to return this response entity. Let's wrap this, and similarly we are going to return a new response entity. Okay, we have to pass the HTTP status dot okay. Alright, and for also put mapping or the update mapping, we are going to change this to response entity. Return new response entity. This will return of employee type. HTTP status okay. So let's save this. Alright, so now you can see for the post mapping we are returning the HTTP status code 201, which is created, and for the delete we are passing the HTTP status no content, which is 204, and similarly for the get employees or get single employee, and for the put mapping updating the employee we are returning the HTTP status code okay, which is nothing but 200. So this way we have to send the HTTP status code back to the client. With the help of the status codes, the client will send a proper messages to the user. So this is a good practice we have to always follow. We have to always pass the proper HTTP status code back to the client whenever we are creating the REST APIs or working with the RESTful web services. Alright, with all this change, let's go ahead and test our work. Let me save this, and our application is restarts. Now let's switch to the Postman, and I'm inside the, first of all let's go to the read employees, and when I click on this send, we do get a single record. And if you look at the status, the HTTP status, which is 200, which is as expected. Now let's go to the create employee, and I'm going to change this to Bharat, and let me change the email address to Bharat. Now when I click on this send, we should get a different HTTP status code, which is 201, and that is created. Our application is working as expected. Similarly, let's test for the delete employee. So we just now created a new record, which is 23. Let's actually delete the same record, delete employee, and let's change this to 23. When I click on this send, we do get a different status code, which is 204, no content. So now we have sending a proper HTTP status code back to the client, and our application is working as expected. Alright, this ends the section, and in the next section we are going to discuss about the pagination and sorting. I will see you in the next video. Hello, welcome back to the course. In this video and in the next couple of videos, we are going to discuss about the pagination, sorting, JPA query methods, and JPQL queries. So let's begin. Before that, I have a very quick announcement. Now you can enroll to my Udemy paid courses directly from my website. So if you head over to my website bhushansirgur.in, and if you click on this image, that will directly take you to the Udemy course, and where you will get a huge discount on this course. You can also directly use this coupon code B2Tech490, and this offer will be available throughout this month, so you can enroll into my course at any point of time. Similarly, you can also enroll to my JSP and Servlets course as well. If you click on this image, that will directly take you to the Udemy course, where you will get a huge discount on this course as well. You can alternately use the coupon code, which is B2Tech 499. You will get the discount on that course as well. You can see the coupon code B2Tech 499. Alright, now let's back to the course. So in this video we are going to discuss about the JPA finder methods. So when we are working with the production grade application, it is very common to retrieve the records from the database based on the column names. For example, we need to retrieve the records based on the name, or based on the location, or based on the age. So such scenarios, it will be very common when we are working with a real-time project. That's exactly what we are going to discuss in this video. So instead of writing the long SQL queries, we can make use of the JPA finder methods or the query methods to achieve such scenarios. So let's go ahead and create a finder method. The very first finder method, assume that we want to retrieve the list of employees based on their name. So let's go to the employee repository, and inside this we are going to write the finder methods or the query methods. So whenever we want to write the finder methods or the query methods, that will start with the keyword find by, followed by the column name. We should not use the database column name. Instead, we have to use the entity class field name, because the entity class field names are mapped with the column names, the database column names. So we have to use the field names. So we want to use the field name. If I go to the employee, we want to use the field name by name itself. So let's use the find by name. We have to create this method in a camel case. So find by name, and this is going to receive the employee name as a parameter, and this will return the list of employees. So let's import the list. So let's save this. So now let's go to the employee service and let's define a new method. This is going to return a list of employee, and I will call the method name get employees by name. This will take the employee name as a parameter. Let's save this, and inside the employee service implementation we need to override the method. Let's create some white space. Let me get rid of these comments, and we need to make use of the employee repository to call the repository method find by name, and we need to pass the employee name as a parameter. So let's save this. All we need to do is we need to call the service method from the controller. So I will quickly create a new handler method, public. We are going to make use of the response entity. We have already discussed about the response entity in the previous video. Response entity of type list of employee. I'm going to call the handler method as get employees by name. I will annotate this method with the @getMapping annotation, and the URI, it's employees / filter by name. We are going to make use of the request param to receive the value from the URI. So @request param string name. We are going to bind the URI value with this value, with this parameter name. Let me change this to response entity. Okay, so now inside this we are going to make use of the employee service to call the service method, return new response entity. Employee service dot get employees by name, and we will pass the name and then we will pass the HTTP status to OK. So with this, let's save our application. Now let's switch to the Postman. I will quickly create a new request. Add request. I will call this read employees by name, and this will be a get request. We will make use of the environment variable to access the variable URL /employees/ filter by name question mark. We are going to pass the query params. Name is equal to, before that, if I go to the read employees, and when I click on this send, we do get a 2 records. So let's filter the records by name Bhushan. When I click on this send, we should get a single record which is a name Bhushan. So if I change this to Bharat, when I click on this send, we should get a single record with the name Bharat. Okay, so let's actually go to the create employee and create a new record with the name Bharat itself. Let's change the department to textile, and this is bharat05@gmail.com. When I click on this send, we do get the response. Now we have 2 records with the same name inside our database. Let's go to the read employees by name and let's click on this send. We should get 2 records with the name Bharat. Alright, so now we have created our very first query method, or the finder method. So remember, whenever we want to create the finder methods, it will start with the find by followed by the field name. We have to use the field names instead of the database column names because the database column names are mapped with the field names. Alright, that's all about this video, and in the next video we're going to discuss more about the finder methods. I will see you in the next video. Hello, welcome back to the course. In this video we are going to continue with the JPA query method. So in the previous video we have written our very first JPA query method, which is find by name. This will retrieve the list of employees based on the name column. So which means this will interact with the single column. What about the multiple columns? Let's say we have a SQL query that look like this, which is select star from table where name is equal to, let's say, Bhushan, and location is equal to India. How to convert this SQL query into query method? Basically we are targeting the 2 columns. So we can easily achieve that by writing the JPA query method that look like this. So this will return the list of employee, and we will start with the find by, because all finder methods or the query methods that will start with the find by followed by the field names. So we want to target the 2 columns. The first column, which is name column, and that name column is mapped with the name field inside our employee entity class. So name, then we will use the AND operator because the query itself says that we want to target both the columns, which is name and location. So we will use the same AND operator inside our query method as well, and followed by the second column name, which is location. The location is mapped with the location field inside our employee class. So location, and we will pass the 2 parameters. One is name and the second parameter is the location. So with this, let's save this. So behind the scenes, the JPA will convert this query method into this SQL query, which is select star from table name where the name is equal to Bhushan and the location is equal to India. So now we have to call this repository method inside our service class. Let's open the service, employee service, and we will declare a new method, which is, this is going to retrieve the list of employee and get employees by name and location This will takes two parameters, name and location. So let's save this. Now we have to override this method inside our employee service implementation. So let's override this method. All we want to do is call the repository method. So return e repository, which is nothing but the employee repository, and find by name and location. So the name, which is nothing but the name that we are accepting from the parameter, and the location. So now with this, let's save our changes, and now inside our employee controller we have to call the service method. Let's go to the employee controller. I'll quickly create a new handler method. I'll just copy the method which we have written in the previous video and I'll paste it. So filter by name, and I'll change this to location, and I'll just accept one more value from the URI. So let's use the request param and string location, and we have to pass the name and location for the service method, and this will be get employees by name and location. With all of these changes, let's save the file, and now let's switch to the Postman, and we will quickly create a new request. And this will be read employees by name and location, and this will be a get request. We will make use of the environment variable, which is URL / employees / find by name and location. Let me verify whether we have the correct mapping or not. Okay, file filter by name and location. So this is not a find, this is filter by name and location. We have to pass the two parameters, which is name, this is equivalent to Bhushan, ampersand, we have to separate it with the ampersand symbol that we have already discussed, and location is equal to India. But let's verify whether we do have these two records in our database or not. If I go to the read employees, and when I click on this send, we should get the two records, but the location is empty. There is no location for these these three records. So what I'll do is basically I'll just update the records. Let's go to the update employee. I need to copy this whole thing. Update employee, I'll get rid of this ID 22. I'll quickly change this to 22, and we don't need this created at and updated at. It will automatically update. Basically I'll change the location to India, and I'll quickly go ahead and click on this send. The record will be updated. You can see it's India. Alright, so similarly let's go ahead and update the other record, and let me copy this. Inside the update employee, I'll paste the code, and I'll change this to, basically I'll change the ID. I will pass the ID, and I'll change the location to Australia, and everything I'll keep it as it is. Let me get rid of this date and time. With all this change, when I click on this send, we should get the response, and the location should be updated. You can see Australia. So now if I go ahead and send the request, we should get a single record, because inside our database we have a record. We should have two records, one is three records, and the one of the location is empty. That's fine. So it should only retrieve the record which is having ID 22. So when I click on this send, we should get a single record. You can see Bhushan, the location is India. If I change the location India to Australia. And when I click on this send, we should not get any errors, but we should get an empty error because the Bhushan and the location Australia does not exist in our database. That's why we do get the empty array, or the results, no results we are getting. But if I change this to Bharat and send, we should get a single record. The name is Bharat and the location is Australia. Alright, this is how we can target the multiple columns by creating the query methods inside the JPA. Alright, in the next video we will look at one more feature provided by the JPA. I will see you in the next video. Hello, welcome back to the course. In the previous couple of videos we have discussed a lot about the JPA query methods, and in this video we are going to continue with the same query methods. Okay, so there are situations we may want to retrieve the employees that contains the keyword. Let's say consider this SQL query. We want to retrieve the employee names that contains the keyword Ram. Okay, so how can we convert this kind of SQL queries into JPA queries? So we can do that easily. There are two different ways. I'll show you both the way. This is going to retrieve the list of employees, and we will start with the find by and the field name, which is name, and we will use containing, and we will pass the keyword, which is nothing but the value. Okay, so this is going to convert this query or the query method into a SQL query that should look like this. The JPA will, behind the scenes, it is going to create an SQL query that should look like this. Okay, there is one more way we can also use that, which is list of employees and find by name. We can use the like operator or the like keyword, and this is going to take the keyword as a parameter or the value. But the difference between these two methods are, anytime if you are using the find by name like, if you are using a like keyword, then you have to wrap your values within the percentage. Let's say you have to wrap your methods that should look like this, percentage, and then you need to append the value, and then again we do have the percentage. Okay, so you have to wrap your values within the percentage, then only this find by name like query will work. Okay, so that's why I don't recommend this method. In case if you want, you can explore this, but I suggest you to use the containing keyword, find by name containing. This will also serve the same purpose. Okay, so with this change, now let's save our changes, and now inside our employee service I'll quickly define a method, get employees by keyword, and we will just pass a single parameter, and let's save this. Inside our service implementation we have to override the method, and we just call the repository method, return eRepository dot find by name containing, and we will pass the keyword. So let's save this. Inside our controller I'll quickly create a new handler method, and I'll change this to filter by keyword, and get employees by keyword. Let me get rid of this. I'll change the employee service, the service method, to get employees by keyword. Let me check what is the method that we are having. Get employees by keyword, get employees by keyword. Alright, so with this changes, let's save the file and our application should restart. And let's quickly switch to the Postman, and I'll quickly create a new request. add request. This will be read employees by keyword, read employees by keyword, and this will be a get request. I will make use of the environment variable, which is URL slash employees slash filter by keyword, and let me verify that filter by keyword, yes it is, and question mark name is equal to, let's say I want to pass the name which is Ram, and right now there is no records that contains the keyword Ram. Let's go ahead and click on this send. We should get an empty array, and let me go to the read employees. Let me go to the read employees, and when I click on this send, we should get a three records. You can see Bharat and Bhushan. Okay, let's say I want to search for the keyword which is BH, okay, that contains the two records, the 23 and the 24. And if I go to the last request and if I say BH, and when I click on the send, we should get a two records which contains the keyword Bharat, not Bharat, BH. Okay, but if I change this to only B, then we should have a three records. When I click on this send, we should get a three records, Bharat and Bhushan. Alright, awesome. So these kind of queries will really helpful when we are doing the search operations anytime in our application. Most of the times we will use this containing keyword. Okay, again you can also use the like keyword, but you have to wrap the values within the percentage symbol. Alright, with this now we have wrap up the section with the query methods, and in the next section we will continue with the pagination and sorting. I will see you in the next video. Hello, welcome back to the course. In this video and in the next couple of videos, we will discuss about the pagination and sorting. I don't go over in detail about what is pagination and what is the purpose of the pagination. I believe that you already know about the pagination. So the pagination is nothing but, let's say we do have 1,000 or 10,000 records in our database, and instead of fetching all the records one at a time, we are going to divide that records into multiple pages. Each page contains certain size or the certain number of records, and when the page number changes, we will get a different set of records. That's the whole idea of the pagination. So in this video we will discuss about the pagination, and in the next video we will discuss about the sorting. So in order to use the pagination and sorting in the data JPA, the data JPA has provided a separate repository for that, and we're going to use that repository. So instead of the JPA repository, we're going to use the repository which is provided by JPA, paging and sorting repository. So using this paging and sorting repository, we can implement the pagination and sorting out of the box. So the first step is we have to call the find all methods that we are going to do inside the service implementation. We have already called the find all method, but this time we are going to pass the two more parameters for this find all method. Not actually the two parameters, we are going to just a parameter which is pageable, and for the pageable we are going to pass the page and the size of the records, and the page number and the size will be provided by the client, because at the end of the day the user interface, the UI, will contain the pagination, the page numbers and the page size. So the user will select the page size and the page number. Depending upon that, we will fetch the records from the database. So since the user will send the page number and the page size, this get employees is going to take two parameters. One is page number and page size, and inside this we are going to create a pageable. It's an interface, and I'm going to call this pages, and we're going to make use of the page request. It contains a static method called of. This will take the page number and the page size. The page number always starts with 0, and we will pass from the 0th index. So let's pass the page number that we are receiving from the user and the page size. And for this find all method, let me actually show you that we have a different overloaded methods. You can see we have a find all which will return the iterable, and we have a find all that will accept the pageable, and there is a one more method which accepts the sort as a parameter. We will discuss about this method in the next video, and basically we are going to use this one. This will accept the pageable because we already created a pageable, and we're going to pass the pageable to this find all method. And of course, if you look at the return type of this find all, this is going to return the page of employees. So but if you look at our return type is list of employees, so we are going to convert that into list. We can convert it to list, or we can even use the get content method. This is going to return the list of employees. With this, now let me save this. Of course, we are getting some error, that is, let me take a look at this. Must be override the employee. Okay, we need to override some method. Okay, this is nothing but the get employees, because we already have this get employees method and we do getting the errors. Because of that, let me remove that and let me save all the packages. Inside our service, we are going to change this to int page number and page size. So now there is no error in our implementation, and we have to call that method inside the controller. And inside the controller, we are going to receive the two parameters. The URI, from the URI we are going to receive the page number and the page size. We are going to make use of the request param, which will be integer page number, and at request param integer page size. And we need to pass the two parameters, which is page number and page size. With this, now let's save our changes. Now let's go to the Postman, and before that I have actually added a few entries in the database just to save some time. So let's go to the, let me close all the requests because we are not going to discuss all these requests. Let's open the the read employees. When I click on this send, we should get a bunch of records, but something is wrong. Let's actually go to the database. We are getting some error. Request page number method is not present. We are getting some errors. That's fine. Okay, actually we should pass the page number and page size. That's why we are getting the error. Before that, let's go to the database. I would like to show you how many records are there in the database. Okay, you can see I have added a few entries in the database, which is employee 1, from employee 1 to employee 12. So we have a 12 records in the database starting from 25 to 36. The ID starting from 25 to 36. So now we need to pass the page number and page size. Question mark, we have to pass the page number. We have already discussed the page number starts from 0 index. So let's go with a 0 and ampersand page size. And the page size, I'm gonna keep it 5. So which means in the first page 5 records, in the second page another 5 records, in the third page we do get the 2 records. So let's keep it 5. We can also keep 10. And when I click on this send, we should get a 5 records, and 1 2 3 4 5. Yes, we are getting 5 records. You can see the employee 1, employee 2, employee 3, employee 4 and employee 5. let's change the page number to 2 and we should get another 5 records. You can see employee 11 and employee 12. I think this is 1. I'm so sorry. Okay, the page number starts from 0th index, so 0, 1 and 2. In the page number when we click the request, we should get the another set of records, employee 6, 7, 8, 9 and 10. Similarly, for the page number 2, we do have only 2 records, employee 11 and employee 12. We can also, just like I said, we can also change it to 10, and I'll change this to 0th index, and we should get the 10 records, employee 1 to 2, employee 10. Alright, this is how we will implement the pagination inside the Spring Boot application using the data JPA. This is a very good handy feature, and yeah, that's all about this pagination, and in the next video we will discuss about the sorting. Hello, welcome back to the course. In this video we are going to discuss about the sorting. The paging and sorting repository also provides support for sorting out of the box, and in this video we are going to see how we are going to use the sorting inside the data JPA project. So what we need to do is let's go to the service implementation, the employee service implementation, and we have this method called get employees by keyword, and for this method we are going to implement the sorting. So we have to sort the employees based, let's say we have to sort it in the descending order or in the ascending order. Let's see how we can do that. So we are going to make use of the sort class. Sort is a class inside the Spring framework, and we are going to make use of the static method by, and to this we are going to pass the direction sort dot direction dot ascending or descending. Let's keep it descending, and we have to specify the column name, but the column name is specified with the field name, and the field name I want to sort it based on the ID. So let's specify the ID, and we are going to pass this sort to this find by name containing method, and we have to modify the repository method. Let's go to our repository, and here this is going to accept the sort, and let's import it from the data.domain.sort package. Now let's save all our changes. Alright, our application restarts. Let's switch to the Postman. Let's go to the read employees by keyword. So right now we are searching for the keyword B, but instead of, let's search for the keyword EMP, and when I click on this send, we should get the record, but in the descending order. You can see the ID starts from 36, 35, 34, 33, 32, 31. Okay, so the records is sorted in the descending order. We can also change this to ascending order. So let's save this. Our application will restart. Let's switch to the Postman. Let me expand so that I can keep track of the messages, console messages. Alright, the application is restarted. Now let's switch to the Postman, and this time when I click on this send, we should get the records in the ascending order. You can see the ID starts from 25, 26, 27 and all the way up to 36. So this is how we can implement sorting inside our application. So now we have learned about the pagination and sorting. In the next video we are going to combine these pagination and sorting, and we will see how it will work together. I will see you in the next video. Hello, welcome back to the course. In this video we are going to implement the pagination and sorting together. Let's begin. So let me go to the service implementation, and inside this we do have this get employees method, and inside this we are already implementing the pagination. So now let's say we want to along with the pagination, we want to sort the records based on the ID. Okay, so how we can do that? So we are going to make use of this same page request off, but this off is a overloaded method, and we can also pass a few more parameters. One is the sort or the direction. Let's pass the direction dot descending and the field name. So I want to sort it based on the ID. Now we are going to pass this pageable to the repository method. Okay, so now this pages or the pageable contains the page number, page size, and the sort direction as well as the field name. Okay, so with this, now let's save our changes and let's switch to our application will restart. Let it restart. You can see our application is restarted. Let's switch to the Postman. Let's go to the read employees, and we have kept the page size as 10 and the page number is 0. So when I click on this send, we should get the records, but it should get in the descending order. You can see now we have a 36 from 36 to till 27, the 10 records, and if I go to that is in a descending order, the last is 27. Now if I go to the next page, let's say 1, and we should get the 26 and 25. Okay, we can also clarify with giving a different size, let's say 5, and when I click on this send, we should get from 31 to 27. Okay, similarly if I go to the 0th page, you can see 36, 35, 34, 33, 32. Okay, so this is how we can use both pagination and sorting. The pageable is actually the page request of method will actually takes 4 parameters. The first parameter is the page number, page size, and the direction and the ID. You can even pass multiple field names in case if you want to sort the multiple fields. Let's say for example name, like that you can give any number of columns. Based upon that it will sort, and finally we are going to pass that pageable to the find all method. Yeah, that's all about the pagination and sorting. So now we have come to the end of this section. This completes the pagination and sorting. I don't go over in detail about all these concepts like pagination and sorting. You can explore by yourself. In the next section we are going to discuss about the JPA one-to-one mapping, one-to-many mapping, and then we will cover the Swagger API. So I will see you in the next section. Hi, welcome back to the course. In the previous couple of videos we have discussed a lot about the pagination, sorting, the JPA finder methods or the query methods. Now it's time to understand the JPQL queries. So why we need JPQL queries and how to write the JPQL queries in our Spring Boot application. So assume that there is a scenario we cannot convert the SQL queries into the finder methods or the query methods. In such scenarios we will write the JPQL queries. So in real world production grade applications it is very common to write the JPQL queries, and in this video we will try to create a simple JPQL queries to fulfill one of the requirement. Okay, so let's assume that we have an SQL query which is select star from table name, which is tbl underscore employee, and where the name is equal to Bhushan or location is equal to India. So let's execute this query. I'm going to execute the query. We should get the 2 records. The location is India and we have the name Bhushan. Okay, so assume that we have to write a JPQL queries for this SQL queries. By the way, we can easily convert this SQL query into the query method or the finder method, but the point here is to understand how to write the JPQL queries. So assume that somehow we cannot convert this query into the finder methods, and now we need to write a JPQL query for this SQL query. So let's see how we can write that. Let me go to my project and inside the employee repository I'm going to write a new method. So this is going to return a list of employee, and I'm going to create a method name which is get employees by name and location. Okay, so here we don't need to follow any conventions, just like how we are following the conventions in finder methods or the query methods. We can give any name we want, but give a meaningful name. I intentionally give it as an and instead of or. So let's go ahead and complete this method. This is going to take two parameters. One is string, which is name, and the second parameter is the location. So when we are writing the JPQL queries, we have to annotate that method with the @query annotation. @query, and inside this we are going to write the JPQL query. So the JPQL query always start with where, not where. We're going to start with from and the table name. But here the table name is mapped with the entity name, the entity class. So we're going to provide the entity class name. In our case, it's employee, and where clause, where the column name. But here the column name is mapped with the field name. So we will provide the field name inside our entity class, which is name is equal to, we're going to provide the variable name that is prepended with the colon the variable name, the variable name, the variable name should match with the parameter name. In case if you want to change the, if you want to give a different name to the method name, let's say for example I have given it as, instead of name I have given it something ABC, then you have to annotate this with the @param annotation. Then you have to provide the variable name, which is name. Okay, so now this name variable is mapped with the, or the value should be bind with the ABC value. But if you're providing a same variable name what you have given in the JPQL query, then you don't need to specify the @param annotation. So in this case we are using the same variable name, that's why I'm eliminating the @param annotation. And we will write or the location, which is the field name, is equal to location. That's it. So let me import the @query annotation. Okay, so now we have imported the @query annotation. Let me save this. So remember, always the JPQL query starts with the from, then the table name and the where clause, and we will provide the field name instead of the column names, equal to, then we will provide the variable name. If the variable name is same with the method argument names, then you don't have to provide the @param annotation. If you are using a different variable name inside the method arguments, then you have to provide the @param annotation. With this, now let's go to the service. I'll quickly create a new method. This is going to return list of employee, get employees by name and location. This will take two parameters, name and location. Okay, we already have this method. Let me change this to or. Let's save this. Inside our implementation, we have to override this method. We're going to call the repository method, return employee repository. Get employees by name and location. We will pass the name and location to the repository method. Next, we are going to create a controller method. Inside this, I'll just quickly take a copy of this. This will be /employees/ we are going to make use of the path variable because we are already using a lot of methods with the query params. So let's use the path variable. So name / location, get employees by name and location. I think this should also be exists, so let's use the OR. Let me change this to at path variable annotation. We're going to call the employee service method, which is get employees by name and location, not name and location, it's a name or location, and we will just pass the name and location. Okay, with this, now before that I would like to change this is okay, this is a get mapping, that's completely fine, and let's go ahead and save this. Alright, so now let's go and test our work. Let me open the Postman, and inside this I'll just quickly create a new request. I will call the request name as read employees by name or location, and we're going to make use of the environment variable, which is URL / employees / we will provide the name and location. It's Bhushan / location India. When I click on this send, we should get 2 records. That is expected. The name is Bhushan, he is from India. Prashant, he is from India. Awesome. So this is how we can create the JPQL queries, and we should annotate that JPQL query with the at query annotation, and we have to use the field names instead of the column names, and we have to use the variable names that is prepended with the colon. I hope you understand how to write the JPQL queries. So this is for the read queries or the select queries. In the next video we will see how to write the JPQL queries for the delete operation. So I will see you in the next video. Hi, welcome back to the course. In this video we will continue on discussing with the JPQL queries. So in this video we will see how to write the JPQL query for deleting the employee record. Assume that we have a scenario where we need to delete employee record based on the employee name, and we are going to do this by writing the JPQL queries. So let's begin. So I'm inside the employee repository. I will just write the JPQL query. So let's start with at query annotation, and we will write the JPQL query. We know that the JPQL query will start with from, but this is not a select query, this is a delete query. So we will start with delete from table name. Instead of table name we will use the entity name because the table name is mapped with the entity. Employee where name is equal to, we need to provide the variable name. So I will provide the variable name as :name, and now we are going to write the method, which is delete employee by name string name, and the return type will be, so remember one thing, when we are writing the JPQL query for updating, deleting or creating, then the return type will be either void or either int. Okay, we should give only these two return values, that is int or void. So in this case I will just return int. I'm going to explain what this integer will do. So whenever this query has been executed, then this method is going to return an integer. This integer is nothing but the number of counts that this query has affected. Okay, let's say if we have a employee names Shankar in the table 2 records, then if this query executed, then this is going to return the count of 2 because it has deleted 2 records that's matching with the records in the database. So this will return 2. So basically this integer will do is it will return the number of the counts that this query has affected. If it is affected 100 employees records, then this will return 100. That's the whole idea of this. Okay, void, it will not do anything, but in this case we are going to return an integer. We want to know the count of the records has been affected by this query. Alright, so now let's save this. Now we have created the JPQL query for the delete method for deleting an employee. Now let's go to the service. Let's quickly create a method delete by employee name. This will take the employee name. Let's save this. Let's go to the service implementation. Let's quickly override the method. We will just call the repository method employee repository dot delete employee by name, and we will pass the employee name. So let's save this. Let's go to the controller. Let's quickly create a new handler method. This will be delete mapping. Slash employees slash delete and name. So this is delete employee by name. We're going to make use of the add path variable annotation to retrieve the employee name from the URI. And we're going to call the service method, which is delete employee by name. And of course we know that this is going to return the integer, and instead of the list of employees we're going to change it to integer. This will also return an integer. Awesome. So what I'll do is, for this I'm going to attach a message that is number of records affected or number of records deleted. Okay, in that case we need to change this to string, and I'll change this to string. Awesome. Okay, so with this changes, let's save our file and let's go to the Postman, and I'll quickly create a new request, add a request. This will be delete mapping, and the request name will be delete by name, and we're going to make use of the environment variables, which is URL slash employees slash the name of the employee, which is Bhushan. And when I click on this send, we should get the message, but for some reasons method not allowed. Obviously this is delete mapping and employees slash delete slash name, Let's go back and see. Okay, I should add delete slash Bhushan, employee slash delete slash Bhushan. Yes, it's good. Click on this send. We should get the message. Okay, all right, I got it. What happened? Let's go to the repository. Okay, so remember one thing, whenever we are writing the JPQL queries, that is for modifying queries, then we should annotate this with the @modifying annotation. Let me import this. Okay, so remember, whenever we are writing a query, the JPQL query is for deleting, updating and creating. At the time we have to annotate that method with the @modifying annotation, otherwise it will throw an exception. Okay, just like we have seen. Okay, so remember that we should use @modifying annotations for modifying queries. Okay, for the select queries we don't have to annotate this with the @modifying annotation, but for other modifications like delete, update and recreate, we should annotate that with the @modifying annotation. With this, let's save our changes. And also we need to add one more annotations, but let's actually test it without that annotation. Let me go to the Postman, and when I click on this send, obviously again we get the error. That is because we have to annotate with @transactional as well. Transactional. So let me import this. We have two transactional. One is javax.transaction and from the org.spring framework. Make sure to choose from the org.springwork.transaction annotation instead of javax.persistence. So with this, let's save our changes. This time our REST endpoint should work. Let's verify, finger cross, and let's click on this send. Obviously the record has been deleted. One number of records deleted. Okay, so let's try for one more record. We know that we have a record which is Shankar, Prashant and Chetan. Let's actually delete the Chetan. Let me copy this and I'm going to delete the Chetan record. When I click on this send, again we should get the message which is one number of record deleted. If I go to the read employees, we should not see Chetan and Bhushan. Yes, we do not have the records Bhushan and Chetan. Okay, so remember, whenever we are writing a JPQL queries for modifications or the modification queries like delete, update and create, we should annotate that with the @modifying annotation, and also we have to annotate with the @transactional annotation, and make sure to import the @transactional from the org.spring framework package instead of javax.persistence package. Alright, so now we have learned how to write the JPQL queries for the select queries as well as the delete queries. You can try for update and create, and in the next video we will discuss about the relationship with one-to-many, many-to-one and many-to-many relationship with the data JPA. I will see you in the next video. Hi, welcome back to the course. In this video and in the next couple of videos, we will be discussing about the relationship between the tables. We will discuss about the one-to-one mapping, one-to-many mapping, and also we will try to cover the many-to-many mapping. So let's begin. So far we have been working with the employee tracking application. I have just restructured the application. Let me show you quickly. So inside the employee entity class, I have removed all the columns, just keeping the ID and the name. And also inside the employee repository, I have removed all the finder methods. And similarly inside the service class and the controller, I have removed all the methods. I have just kept the CRUD operation methods, which is create, read, update and delete. Alright, so now let's go to the employee class. So inside the employee, we have an ID and a name. So earlier we have created a field called department that will be a string column, but this time we're going to separate that department and we're going to create a new entity class. We're going to keep a separate entity for the department, and each employee belongs to a department. And then we're going to set up the one-to-one mapping between the employee and the department. So I'll just quickly create the new entity class. And inside this we're going to add the annotations. So let me go to the employee and I will just copy all the annotations and I'll paste it at the top. Similarly, I'll copy these two fields and I will paste it inside this class, and I'll just change the table name to department. And inside this department we have two fields, ID and the department name. Now we have to set up the one-to-one mapping between the employee and the department. So inside the employee, I will go ahead and create a new reference variable for the department, private department, and this will be department. And since this is a one-to-one mapping, we need to add the join column. So let's add the join column annotation. We have to provide the column name, so I will provide department underscore ID. You can give any name, and I will also add the annotation, which is one-to-one. Alright, so now we have created a relationship between the employee and the department. So similarly, we have to create the repository for the department, just like how we have created the employee repository. So inside the repository package, I will just quickly create the interface. This will be department repository, and this will also extend the JPA repository, and the entity name, which is department, primary key type long. Let's import the department. I will quickly add the repository annotation. Alright, so now we have created the repository for the department, and also we have created the entity class. And now inside this employee, we need to create a constructor. So let's create the constructor, and this is going to receive a request object. We're going to create a separate request object. So first go ahead and create the request class. So I'll just create a separate package for that, and this will be request, and inside this we're going to create a employee request, and this will be a plain Java object. This contains private fields, setters and getters. Let's quickly add these setters and getters. This contains two fields, that is employee name and the department. So inside the JSON payload, we are going to send the employee name and the department, and inside our controller we are going to separate that. We are going to store the employee details in the employee table and department details in the department table. Let's import the add setter and add getter. Alright, so now inside the constructor, inside our employee class, we are going to receive the employee request. This will be the request. So let's import the employee request, and inside this we are going to assign the fields. This dot name is equal to request dot get name. That's it. So let's save this. Let's save all the files. Alright, now what we need to do is inside our controller, right now what we are doing is we are just receiving the employee object and then we are storing it into the database. But now since we have set up the relationship between the employee and department, so here the department is the parent class and the employee is the child class, because the department reference variable is present inside the employee. So unless we save the department object, we cannot store the employee object. So first we need to store the employee details, and once we store the employee details, we do get the department ID, and that we have to set it to the employee class object. So let's modify our controller handler method. So inside this we have this post mapping. First of all, we are going to remove this employee. Instead of employee, we are going to receive the employee request. So we do get the employee request, and this will be e request. So let's import the employee request, and let me get rid of this return statement. First we need to create the department object. So department and dept is equal to new department. Let's import the department, and then we are going to set the department name, which is that we will get it from the employee request object. So e request dot get department, and once we set the department, now we need to save this department to the department repository or the department table. So first we need to auto wire this. So for now what I'll do is I'm not going to use the service layer, I will directly store it to the repository. So let's auto wire the repository, which is department repository. Thus this will be department repo. Let me auto wire this. So inside this, what we need to do is we are going to call the repository method drepo dot save, and we are going to pass the department object. Once it is saved, we do get the department object, which is having the ID, department ID. So once we save the department object to the database, we do get the department ID that we have to set it to the employee object. So let's create the employee object. Employee, let me call this employee is equal to new employee, and to this constructor we are going to pass the employee request, and finally we are going to set the employee dot set department. We are going to set the department, and finally we need to save this employee object to the employee table. So we are going to call the employee repository method, but we do have this employee service. For now what we'll do is directly we will save to the database. Let's auto wire we will not use the service layer as of now. So let's auto wire the private employee repository e repo. Let's auto wire this as well. Let me import the employee repository, and inside this let's actually call the save method erepo.save, and we're going to pass the employee object. So this will return the employee object that will be having the ID. Now we can return the response entity, and we are going to pass the employee object http status to created. Alright, so now let's save this. Let's save all the files. Let's test our work. Alright, our application is started. First let's go to the database and let's refresh the database. The tables has been created, and now let's go back to the Postman. Let's go to the create employee, but this time we're going to pass the name and the department. That's it. Let me get rid of this email and location, and the name will be Shankar and department will be civil. Let's go ahead and click on this send. We should get the response. As you can see, the ID will be 1, name will be Shankar, department, a department object which contains the ID and the name civil. So let's actually go to the database and see how it is stored in the database. So if I open the employee table, and you can see we have a ID, name and department ID, and you can see the employee ID will be 1, the name will be Shankar. And if you look at the department, we have a one new record which is ID is 1 and the department name is civil, and this ID, the department ID, is a foreign key to this employee table, and you can see the department underscore ID is the record of ID of 1. Okay, let's go ahead and try for one more record. I will change this to my name, Bhushan. I'm an IT guy, and let's go ahead and click on this send. We should get a new response. ID will be 2, name Bhushan, department ID 2, and the name will be IT. So this is about the one-to-one mapping with the data JPA. I hope you understand about the one-to-one mapping with Spring Data JPA. In the next video, we will discuss about the other mappings like one-to-many and many-to-many. I will see you in the next video. Hi, welcome back to the course. In this video, we are going to create an inner join query using the data JPA. So let's begin. So what I'll do is, before that I would like to show you the database records. So inside the database I have created a few records. So if you go to the department, I have inserted few records. I have inserted 5 records. Similarly for the table employees, I have entered the few records. So now our idea is we need to retrieve the list of records, list of employees that belongs to the department, the IT department. So if I go to the table department, we have 2 records that belongs to the IT department, the 2 and 3. So if I go to the department ID 2 and 3, the Bhushan and Bharat. So these 2 employees belongs to the IT department, and we have to retrieve these employees. So how we can do that? So there are a couple of ways to do that. I will show you all the ways. So first let's actually write the query method for this. So that query method internally converts it into a join query. The JPA will convert that into a join query, and it will fetch the records for us. Let's go to the STS. Let's go to the employee repository, because we have to retrieve the records from the employee table. So we have to write a finder method inside the employee repository. So inside this we are going to write a method. This is going to return the list of employees, and find by, that we know that the query method starts with find by, and we need to start with department. So because we have to get the employees based on the department name, but inside the employee table we do not have a direct access to the department name. We have to access to the department reference variable. So find by department, and once we get the department object, inside the department object we do have 2 fields, the ID and the name. So we have to fetch that department name. So find by department name, and this is going to take the department name as an argument. That's it. So now let's save this. Let's go to the controller. Let's quickly create a handler method, public. This is going to return the response entity of list of employee, get employees by department, so let's add the get mapping annotation, and this will be /employees. Let me check if I can use the request param. I cannot use the request param because we already have the delete mapping, but we can use because get mapping, it is having the path variable. So let's actually use the request param at request param, and we are going to receive the department name from the query params. Alright, so what we need to do is inside this we're going to call the repository method. So return new response entity of list of employee. We're going to call the repository method, which is eRepo dot find by department name, and we're going to pass the department name, and let's pass the HTTP status to OK. So let's save this. So now let's go to the Postman. Our application is restarted. Let's go to the Postman. I will quickly create a new request, add new request, and this will be read employees by department. This will be get request. We will make use of the environment variable URL / employees (name is equal to IT), and when we click on this send, we should get the 2 records, but something is wrong. We are getting some exception. Let's go to the expand this. Okay, some ambiguous mapping cannot map employee controller method. Okay, no worries. Let's actually change this to, let me change this to /employees/ we are going to make use of the path variable, but still the path variable is also there. What we can do is let's use filter / then we will make use of the branch name or the department name. Okay, let me remove this request param. Let's use path variable. So let's save this. Let's go back to the Postman. Let me get rid of this /filter /IT. When I click on this send, we should get the record, but still no default constructor. Obviously this is expected. Let's go to the employee. Since we have created the parameterized constructor, we have to create the no argument constructor. Let's create the, we will make use of the Lombok, which is no args constructor. With this, let's save our changes. This time we should not run into any errors. Our application is restarted. Let's switch back to the Postman. When I click on this send, we should get the 2 records, which is Bhushan and Bharat, that are belongs to the department IT. We can try for other as well, civil, and there is only 1 record which is available, I guess. Click on this send, we should get a single record. The employee name is Shankar. Alright, this is one way we have creating the finder method. Internally the JPA will convert this into an inner join. Okay, it will add the join column and then it will fetch the records. We can prove that. Let's go back to the STS, and inside the application properties I'm going to add one more property, which is JPA.showSQL, and I'll set this to true. This is going to execute the display the queries that it has executed inside the console. Let me go back to the Postman again. When I click on this send, if I go back to the console, you can see there is a SQL query that has been executed, and you can see the first SQL statement. It has some, okay, you can see left outer join. Okay, using the left outer join, the JPA will convert that query method into left outer join and it will fetch the records for us. Okay, so this is a one way, and there is one more way. We can use JPQL query to retrieve the records. In the next video, we're going to see that. I will see you in the next video. Hi, welcome back to the course. In this video, we're going to write the same join query using the JPQL query. So let's begin. So let's go to the employee repository, and inside this we are going to create a method. This is going to return the list of employees. The method name, which is get employees by department name. You can give any name you want. This is going to take the department name as a parameter, and we are going to add the add query annotation. And we know that we have to start from so from table name, but the table name is mapped with the entity name, which is employee, from employee, where the department, here the department is the field name, department dot, the department entity class contains two fields, ID and name. So we have to use the field name, which is name. So where department dot name is equal to, we're going to use the variable which is name. So that's it. We don't need to add modifying annotation or add transactional, because we are not dealing with the modifying the queries or modifying the records. We are just working with the select queries, so we don't need to add those annotations. So with this, now let's save this file. Let's go to the employee controller, and inside this I'll just quickly comment this, and then we are going to call the new method, which is return new response entity. This is going to return the list of employees. Repository dot get employees by department name, and we're going to pass the department name. HTTP status to OK. That's a typo error, so let's save this. Our application is restarted. Let's go back to the Postman, and let's actually change this civil to IT, and when I click on this send, we should get two records that we have seen already, the Bhushan and Bharat. So alright, now we have see how we can create the join queries using the finder methods as well as the JPQL queries. And in the next video, we're going to discuss about the other mappings like one-to-many and many-to-many. I will see you in the next video. Hi, welcome back to the course. In the previous couple of videos, we have discussed about the one-to-one mapping with employee and department. In this video, we're going to discuss about the one-to-many mapping. We're going to take the same example, employee and department this time, and each employee belongs to a multiple department. So that will be the one-to-many mapping. So let's see how we can achieve that. So inside the employee class, previously we have added the department because we are working with the one-to-one mapping. So instead of this, we will go for the one-to-many mapping. So the employee does not contain any departments, but the department will contain the employees. So many departments can contain the one employee, or many departments belong to a single employee. So that's why inside this department we are going to create the reference variable for the employee, and this will be employee, and we are going to use the many to one annotation. So many departments can belong to a single employee, so many to one, and we need to add the join column annotation. The column name, which is employee underscore ID. So let's import these annotations, and inside this employee.java we have removed that. So now let's save that. Before that, let's go to the MySQL database and let's drop these two tables. let me drop the department and the employee. So I think first we need to drop the employee table, then we need to drop the department table. Alright, so now we have removed these two tables. Now let's go back to this and let's actually save the file. And inside this employee controller we do get this error. That's completely fine. Let's remove these things because we're going to write a new logic inside our post mapping. So let's save this. Let's actually return the null, otherwise we will get an exception inside our application. Still we are getting some exception. Let's actually see that exception. No property department found for the type employee. That's fine. Let's go to the SQL. Let me refresh this. We should get the two tables, the department and employee. So if I click on this, and inside the employee we have two columns, ID and name, but inside the department we have three columns, which is ID, name and employee ID. Alright, so now let's go to the employee request. So we have created a new request, which is employee request. So this time we are also going to pass the list of departments. So this will be list of departments. So it will be a list of strings. So let's import the list. Alright, so let's save this. And now inside our controller, let me go to the controller. Inside the post mapping, we're going to write a new logic. So first, in the previous one-to-one mapping, the department was the child and the employee was the parent. But here in this case, first we need to save the employee object. Once we save the employee object, then we're going to set the employee object to the departments. So that's the whole idea. So let's create an employee object. So we will create employee, new employee, and we're going to pass the employee request, which is e-request, and then we're going to make use of the employee repository to save the record, e-repo dot save. We're going to pass the employee object. This is going to return the employee, which is having the ID. And after this we do get we need to save the department. So but here we are getting the list of departments, so we have to create a new department object. So for that we're going to loop over the list of records. e-request dot get departments. This will be a string type. Inside this we are going to create the department object. Department d is equal to new department, and for this d dot set department name, that will be yes, and also we are going to set the employee, which is the above one. So now we have set the department name as well as the employee. Now we need to save this department. So for that we are going to make use of the department repository, drepo dot save, then we are going to pass the department. And finally we are going to return the employee. In fact we have to return the we can return anything, but as of now what we'll do is, let's actually print a message, return new response entity of type string, record saved successfully. Let's set the HTTP status to created. Alright, so let's save this. All we need to do is we need to test our work, but before that we are getting some exception. Let's actually first resolve that exception, which is no property department name found for the type employee. Okay, let's go to the employee. Okay, this is nothing but the find by department name. Alright, let's go to the repositories. Let's get rid of this. We also get rid of this. So let's save this. This time we should not get any errors, obviously. Yes, now let's go to the, okay, inside the employee controller we have few errors. Let's get rid of this as well. Hopefully there is no errors in our application. That's fine. Let's go to the Postman. Let me close all these things. Let's go to the create employee. And previously we are passing only the single department, but instead of this, now we are going to, first of all, let's go to the employee and employee request. We have this department and name. So the department that will be of type array. So within the square brackets we're going to pass the departments, let's say IT and civil. So now let's go ahead and send the request. Record has been saved successfully. Let's go to the MySQL database. First of all, let's actually execute the table employee. We should get the single record, which is Chaitra, and the Chaitra ID is 1. Inside the department we should get the 2 departments, and that is mapped to the Chaitra's ID, which is 1. Okay, so this is nothing but the one-to-many mapping. I hope you understand about the one-to-many mapping. That's all about this video. Thank you so much for watching. I will see you in the next video. Hi, welcome back to the course. In the previous couple of videos we have discussed about the one-to-one mapping in JPA. So if you observe carefully, so we are discussing with the employee and department. So inside the employee we have a reference variable for the department. So whenever we get the employee object, we also get the department object. But if you look at the department class or the entity class, we do not have a reference variable for the employee, which means whenever we get the department object, we do not get the employee object, the associated employee object. So this is nothing but the unidirectional, which means there is only one way to access the department from the employee, but inside the department we cannot actually get the employee object. So in order to get the objects in both the ways, in both the cases, then we have to go for the bidirectional. So in this video, let's see how we can achieve the bidirectional. So it's very simple. We are going to create a reference variable inside the department as well. So inside the department, we are going to create a new reference variable for the employee. So this will be employee. And we are going to add the same annotation, which is 1-to-1. And we are going to add one more option to this 1-to-1 mapping or the annotation, which is mapped by. And we are going to provide the field name, which we have mapped inside the employee. So inside the employee, we have mapped for the department field, and that field is the department itself. Let's copy this, paste it. With this, let's save our changes. And now let's go to the controller. So we will go to the employee controller. So inside the employee controller, we have already written the post mapping and we are saving the employee object. Okay, so now let's actually fetch the department, the list of departments, and when we fetch the list of departments, we should also get the employee record. Okay, so for that I have already created a separate response object. So let me open that. Department response. It is just a plain old Java object. It contains some private fields and setter and getters. So we have the ID and the department name and the employee name. And I have created this inside the separate package, which is response package. And now we have already created the department repository. Let's go to the department controller. So inside the department controller, let's actually write the handler method to fetch the list of departments. This is going to return the response object, the list of response object, department response, get departments, and inside this we're going to make use of the department repository to call the find all method, and this is going to return the list of department. This will be departments. So now we are going to create an empty list which is of type department response. Department response, this will be list is equal to new array list. And now we are going to loop through these departments that we have fetched from the repository. We are going to make use of the lambda, and inside this we are going to create the department response object. Department response dResponse dot set department name d dot get name. Similarly, dResponse dot set id d dot get id, and dResponse dot set employee name, that will be d dot get employee, because inside the department we do not have the employee name, we have to access through the employee object. So get employee dot get name, and then we are going to add this dResponse to the list. And finally we are going to return the list. Alright, so now let's save this. Our application is restarted. Let's go to the Postman, and I'm inside the create employee. So let's go ahead and create a new employee. I'm going to create with my name Bhushan. I'm an IT guy, and click send. We should get the response. So the ID 3, name Bhushan, department is IT, and the employee will be null. Okay, this is fine, no worries. Okay, we should have created a new employee response, but we haven't created the new employee response, so that's why it is going as null. Okay, so now let's go to the read departments, and inside the departments right now there are 3 records. I have already inserted the 2 records previously, so let's click on this send. We should get 3 records, but we are getting some exception. This is, let's see, /API v1 /departments. Okay, let's go to the, and let's check for department name and department. I think we have missed something. Let's actually go to this departments. Okay, I even not added the get mapping at all, so let's add the get mapping. This will be departments. Super. So our application is restarted now. Let's go back to the Postman, and we should send the request. We should get the 3 records, that is the department civil, and the employee name is Chaitra, and the department name is IT, the employee name is Bharat. Similarly, the employee name is Bhushan and the department name is IT. Okay, so we have created a separate response object for the department, and similarly we should have created the employee response, but I just go with the flow. That's completely fine. You can create a new employee response and you can map it just like how we have mapped in this. Alright, this is all about the bidirectional in one-to-one mapping, and in the next video we will cover the bidirectional in one-to-many mapping. I will see you in the next video. Hi, welcome back to the course. In the previous couple of videos we have discussed about the one-to-many mapping, and in this video we are going to see how to achieve the one-to-many mapping with the bidirectional. So if you look at the existing application, like inside the employee and inside the department, so inside the department we have this many-to-one mapping. So this department entity contains the employee reference variable. So once we get the department object, we also get the associated employee object. But inside the employee object, if we get the employee object, we don't get the departments. Okay, so the each employee, how many departments he is associated with that, we don't get that information. So in order to achieve that requirement, we are going to make the one-to-many bidirectional. So inside this employee, we are going to create a reference variable for the department. Let's see how we can do that. So inside this, what we are going to do is we are going to create a reference variable for the department which will hold the list of departments, because we have already seen that, I'm sorry about that. So we have already seen that inside the department, this will be the many-to-one, which means many departments will be associated to a single employee. But inside this employee, so inside this employee, one employee is associated with the multiple departments. So in this case it will be reverse, one-to-many. But if you look at from the department side of view, that will be many-to-one. So inside this we are going to create a reference variable for the department that will be a list type, and we are going to annotate with the one-to-many mapping, one-to-many annotation, and we are going to add the mapped by option, much like we have added inside the one-to-one mapping bidirectional. So mapped by, and we are going to provide the field name inside the department entity. So once we have set up this one-to-many and many-to-one inside these two entities, inside our controller we are going to make a few changes. So first of all, our post mapping will be remain same, and this will return the string. Once we store the record into the database, we will get the record saved successfully. After that, we are going to write the get mapping for retrieving the list of employees. So let me uncomment this. So I have already written this method. I will just explain what I have written inside this method. So inside this, first of all, we are going to retrieve the list of employees from the repository. So this will return the list of employees, and then we are going to create a employee response. Okay, I have created a new employee response, much like how we have created the department response. So this employee response contains few fields like ID, employee name, and the departments. Again, the department will be of list type, because and each employee mapped to a multiple departments. So this will be a list of strings. And inside this we have created the list of employee response, and then we will loop through the repository list, that is the database records, and each time when the loop runs we are going to create a new employee response. So and inside this employee response we are going to set the fields like the ID and the employee name. But for the departments, we know that employee response contains the list of departments. For that we are going to create a new list that will be of string type, and then we are going to loop through the departments that is coming from the employee repository. Okay, and we are going to add that to the departments list. So each time when the department runs, we are going to add it to the department's empty list. And finally we are going to add this department to the employee response. So once we prepare the employee response, we are going to add that employee response to the response list, and we are going to return the response list back to the client. So this method is pretty straightforward. I think you guys can easily understand this. There is nothing much in this method. We are just setting and getting and setting the information to the employee response. We have created a new employee response and we are setting the associated fields to that entity class. So let's save all our changes and our application will be restarted. Let's go back to the Postman. First of all, let's go to the create employee. So I have already inserted a few records, so I'll just insert a new record which will be Chaitra, and the department, she is from mechanical, and one is civil. So when I click on this send, we should get the message record saved successfully. So now let's go to the read employees. As I said, I have already inserted 2 records and now we have inserted one more record. So this time we should get the 3 records. So let me get rid of this, because this time for the get mapping we are not using any pagination or sorting. We're just sending the /employees. So when I click on this send, we should get 3 records, that is the employee name Bhushan, employee name Bharat and Chaitra. Just now we have added the department will be mechanical and civil. So this is all about the one-to-many bi-directional. So we have discussed about the JPA mappings one-to-one, one-to-many, both in unidirectional and bi-directional. So the advantage of using bi-directional is from both the sides we are able to access the entities. Alright, that's all about this section. I will see you in the next video. Hi, welcome back to the course. In this video, we will discuss how to write the native SQL query inside the data JPA. Let's begin. We have been working with the employee management application. So we have the employee controller, employee repository and the employee entity. So inside the employee entity, we have the ID, name and location. And inside the employee controller, we have already written the post mapping, which is going to store the employee records to the database. And inside this employee repository, we are going to create a new method and we are going to use the native SQL query to retrieve the list of employees. So there are a couple of ways to use the native SQL query inside the data JPA. We're going to discuss one by one. So the first way is by using the @query annotation. So inside the employee repository, we're going to create a new method. This is going to return the list of employees. And the method name, you can give any name. I will call this get employees. And we are going to annotate this method with the @query annotation. So first of all, let me import the list interface. Now let's use the @query annotation. This is going to take 2 options, the value and the native query. So the value, which is nothing but the SQL query, and the native query, which is nothing but the boolean value. So we're going to set this to true, which means we are going to write the native SQL query. So the value, it will takes the raw SQL query. So in this case, it's select star from employees, the table name, which is tbl underscore employee. Let me go to the database. Okay, let's go to the employee and you can see the table name is tbl underscore employee. So select star from tbl underscore employee. So now let's save this and let's go to the employee controller. We're going to create a new handler method, public. This is going to return list of employee and this will be get employees. And we're going to return the list of employees. We're going to call the repository method, which is eRepository dot get employees. So let's import the list. Let's quickly annotate this with the @get mapping annotation. This will be /employees. Let's quickly import the get mapping annotation. Let's save all the files and let's go to the main class, or you can click on this run button. Let me expand the console. Alright, you can see the table has been created and the application is started. Let's switch to the Postman, and we have the /employees post mapping, which is going to create the employee records. So this will take the request body, which is name and location. The ID will be automatically created. So the name Chaitra, location India. When I click on this send, we should get the response. Okay, so let's change this to my name, Bhushan. I'm also from India. When I click on this send, we should get the response. Alright, so now let's go to the new tab, and this will be a get request. We are going to make use of the environment variable, which is URL/employees. When I click on this send, we should get the two records, the ID1 and the ID2, Chaitra and Bhushan. So this is how we can create the native SQL queries inside the JPA. So we are going to make use of the add query annotation, and then we're going to set the native query flag to true. Alright, in the next video, we're going to see one more way of writing the native SQL query inside the data JPA. I will see you in the next video. Hi, welcome back to the course. In this video, we will discuss one more way of writing the native SQL query inside the data JPA. So for this, we are going to make use of the @named native query, and also we are going to make use of the Hibernate entity manager. So let's begin. So what I'll do is I'm going to create a new package inside the source main Java, and the package name I'm going to call is Davo package, which is Davo, and inside this we're going to create a new class, and this will be employee Davo. Implementation, and I'm going to annotate this with the @repository annotation. Let's import the @repository. So inside this, we're going to create a new method. So before that, inside the entity, which is the employee entity, we're going to annotate this class with the @named native query. Let's import this. This will take a couple of options. The first option is name, which is nothing but the name of the method. You can give any name you want. I will call this get all records. The second parameter, or the second option, which is nothing but the query, which is nothing but the SQL query. So this will be select star from table name, which is tbl_employee, and the third option, which is nothing but the result class, which is nothing but the mapped class. Once we execute this query, the records, all the records to which class it should have been mapped, so that will nothing but the result class. So result class, that will be employee.class. Okay, with this, let's save the employee.java file. Now let's go to the employee Davo implementation, and inside this we're going to create a new method, which is public. This is going to return the list of employees, so list of employee, and you can give any name you want. I will call this get all, Let's import the list and the employee as well. So inside this, we are going to make use of the entity manager to call the create named query method. So first of all, let's not auto wire, we are going to make use of the persistence context. So let's use at persistence context private entity manager. I'm going to call this manager. Let's import the entity manager, and now we're going to make use of the entity manager to call the create named query method, and this will take a couple of options. The first option, which is nothing but the method name. So let's go to the employee.java. So here we have provided the native query name, which is get all records. Let's copy this and paste it here. And the second option, which is nothing but the mapped class, it's employee.class, and we're going to call the get result list, and we need to return it. Now let's save this file. Let's go to the employee controller, and we're going to either we can create a new handler method, or we can use the existing method which we have created in the previous video. So I will use the previous method. Like in previous video, we have created this get employees method. So let me comment this return statement, and inside this we are going to call the DAO implementation method. We need to auto wire the DAO implementation employee DAO implementation. I will call this DAO. Let me auto wire this. And now inside this we are going to return DAO dot get all, and let's save this. Our application is restarted, and now let's switch to the Postman, and we are inside this /employees, which is the get request. When I click on this send, we should get the same response which we are received in the previous video. We have two records, the ID1, ID2, which is Chaitra and Bhushan. So let's actually quickly create one more employee, which is Bharat, and he is from Australia. When I click on this send, we should get the response. And now when I go to the /employees get mapping, when I click on this send, we should get the 3 records, the ID 1, 2 and 3. Alright, so these are the 2 different ways that you can use the SQL queries. Whenever if you are not able to convert the JPQL queries, or you cannot convert the query methods or the finder methods inside the JPA, we can use the SQL queries to fulfill the requirements. So that's all about this video. I will see you in the next video. Hi, welcome back to the course. In this video, we will discuss how to use the @named query annotation. Let's begin. So we're going to use the @named query annotation inside the entity class. So we are inside the employee.java entity class. Let's use the @named query annotation. This will take a couple of options. The first option, which is nothing but the name, which is nothing but the name of the method. I'm going to call this get all records. And the second option, which is nothing but the query, and here we are not going to write the SQL query. Instead we are going to write the JPQL query. We have already discussed about the JPQL queries. The JPQL queries contains the entity name instead of the table name, as well as the field names instead of the column names. So let's write the JPQL query from the table name, but the table name is mapped with the entity name, which is employee from employee. You can write the where condition or the where clause in case if you want to filter out the records based on the columns, but I'm going to keep it simple, from employee. That's it. And now first of all, I'm going to comment this at named native query annotation, because we're going to use the same method names for this. If we use at named native query and the at named query with the same method names, then we will get an conflict, we will get an error. So for now I'm going to comment this, and let's save this. And inside the employee repository, we are going to create a new method, which is nothing but this is going to return the list of employees, list of employee, and the method name. If you go to the employee.java, let's copy the method name, which is get all records, and paste it. That's it. So now let's save this, and inside the employee controller, and let me make use of the same method which we have been working with so far, which is at get mapping annotation / employees. So let me comment this and return erepo, the employee repository dot get all records. You can see this is going to return the list of employees. So now let's save this. Our application will restart, but for some reason we are getting some exception. Let's see that no property get all records found for type employee. That is fine. Let's go to the employee repository. Let me comment this. Now let's save this. This time we should not get any errors, but still we are getting some errors. That is because this is get all records. Okay, all we need to do is we have to attach the entity name, which is employee.getRecords. So let's save this, and this time we should not get any errors. Yes. So whenever you are writing the at named query annotations, then we need to prepend the entity name for the method name. Okay, so let's save this. Now let's go back to the Postman, and when I click on this send, we should get the same records which are available in the database. Let's go to the create employee. Let's quickly add a record, the new record, which is Anand. He is from America. When I click on this send, we should get the response, but when I go to the /employees get mapping, click on this send, we should get the 4 records, the employee ID 1, 2, 3 and 4. Alright, this is how we can use at named query annotation. So at named query annotation, we are going to use at the entity class name, and we are going to prepend the entity name for the method name, and we are going to use the JPQL query instead of the native query. Alright, in the next video we are going to discuss about the documenting our REST APIs using the Swagger. I will see you in the next video. Hi, welcome back to the course. In this video we are going to see how to document the REST APIs inside the Spring Boot using the Swagger. So it's always a good practice to document the REST APIs so that whoever consuming the REST APIs, he can easily view what is the endpoint and what is the JSON payload that we need to send inside the request body, and what will be the response that we are going to get, and what will be the status code that we are going to receive when we make the request, and all these informations we can see in one place. So it's always a good practice to expose the documentation using the Swagger. There are so many tools available to document the REST APIs, and Swagger is one of them. Instead of exposing or instead of documenting inside the document, the Word document or in the Excel sheet, we can easily use the Swagger API to document the REST APIs in Spring Boot. So let's see how we can use Swagger in our Spring Boot application. So far we have been working with the employee management application, and right now we have a controller, employee controller, and we have exposed the two endpoints, which is /employees, which will store the employee records. Also we have a /employees, which will retrieve the list of employees. Okay, you can also add other handler methods as well to perform the CRUD operations as well. So I'm going to keep it simple. So we have two handler methods for creating the records and retrieving the records. So in order to use the Swagger, we're going to add a few dependencies to our pom.xml. Let's open the pom.xml. So inside this pom.xml, we are going to add the two dependencies. So let me quickly copy the dependency and paste it. So the group ID, which is nothing but io.springfox, and artifact ID, which is springfox minus swagger 2, and we're going to add the version as well, which is 2.9.2. and let me copy this again. We're going to add the one more dependency, so which will also be the group ID, which is also be io.springfox, the artifact ID, which is springfox minus swagger minus UI. So for the, it will provide the user interface to see all the REST endpoints and the documentation, and the version we're going to keep it the same. So make sure to use the same versions for both of the dependencies. If you use a different versions, then it will not work. So with this, let's save the changes, and it will download the required jars from the Maven repository. And the next thing, we need to use an annotation to enable the Swagger. So let's open the main class. Let me go to the project explorer, and inside the base package we have the Spring REST API application. So just below the @Springboot application, we are going to use the annotation, which is enable swagger 2, and let's save this. That's it. We don't need to do any extra configurations to document the REST APIs. It will automatically, the Spring Boot will automatically takes care of everything. The Swagger will automatically expose the documentation for us. Now let's go to the browser. Let's go to the URL, which is localhost:8080/swagger-ui.html. Hit enter, and let's go back to the browser. We should get, okay, we are getting some errors. That is fine. Let's stop the server. Let's restart it again. Let me expand the console. Alright, so now let's go to the browser. This is not localhost 8080. I think this is localhost 8080/API/v1/swagger-ui.html. As you can see, the Swagger UI, this is the HTML page that is exposed by the Swagger. So the Swagger UI automatically display all the controllers. So this basic error controller, which is the default controller, not the default controller, it is provided by the Swagger, but the one controller which we have created is the employee controller. So if you expand this, you can see we have two APIs, which is /employees, which is a get mapping, /employees, which is the post mapping, and also we have the model classes, which is the employee model class. Okay, so don't worry about this model view and view. Okay, just if you expand this employee, you can see we have three fields: ID, location, and name. Similarly, if you expand these endpoints, you can see more informations. Okay, so the parameters, the response codes, and the response that we are going to get back when we make a request, and all these options. Even we can try out these endpoints on the go. So for example, this get mapping / employees, if you click on this tryout, and you will see that the execute option, when I click on this execute, and you can see internally it uses curl to make the HTTP request. If you scroll down, you can see the response that we are going to get back from the database or from the server. So we have 4 records, the ID 1, 2, 3 and 4. Similarly, you can try out this / employees post mapping as well. If you expand this, and you can see the response that we're going to get back from the server. And if you click on this try it out, and you can see, let me get rid of this ID, we don't need to pass ID, and the location, which will be string, and this will be the location, let's say it's India, and the name, which is Shankar. And when I click on this execute, and if you scroll down, you can see the curl request. If you scroll down, you can see the response, which is ID 5, the name Shankar, location India. And you can also see the response code, which is 200 OK. So this is all about the Swagger, and this is how you can document your REST APIs in Spring Boot using the Swagger. Again, Swagger is not only the tool to document the REST APIs, there are so many tools available that you can use, and Swagger is one of the most popular, and I will be using this Swagger from the beginning. Alright, in the next video we are going to see how to document the REST APIs using the Swagger Open API 3. So that is coming up in the next video. I will see you in the next video.